Stop building the same apps twice. Seriously, if you're still writing separate code for iOS and Android, you're working too hard. Modern apps need to be everywhere. Phones, tablets, web, and they need to look incredible. That's exactly why Flutter has taken over the world. In this crash course, we aren't just talking theory. You'll go hands-on. You'll master the widget system, build high-performance layouts, and learn the exact workflows professionals use to ship real-world apps from a single code base. To teach you, we brought in the best, Tadas. Tadas is a Google developer expert who has been building with Flutter since it was in beta, and has taught thousands of developers how to build fast and scalable mobile applications. Now, before we hand it over to Tadas, we have a massive surprise for you. We're opening up the Zero to Mastery Discord community for free, but only for a limited time. You can get help from our mentors, find an accountability partner, and work alongside thousands of other developers in the community. The invite link is in the description down below. Make sure to use it before it expires. All right, you ready to get started? Tadas, the floor is yours.
Hello everyone and welcome to the course. For those of you that are completely new to Flutter, Flutter is an open source cross-platform framework that allows you to write code in one place and build for both Android, iOS, even websites, and actually many more platforms including macOS, Windows, Linux, and even embedded systems. And Flutter is built by Google, and they even use it internally for some of the apps that they build. It's also used by many other big companies, including Alibaba, Google Pay, BMW, ByteDance, Tencent, Toyota, and many other applications and companies. It's also been one of the fastest growing frameworks ever since it came out. And every year there's a survey published by Stack Overflow, and every year Flutter is one of the most loved frameworks out there. Now a little bit about me and my relationship with Flutter. So my name is Tadas, and I've been working with Flutter since back in 2018. At this point, it was still in the beta stage, so before it was officially released for everybody to use with the 1.0 version. And then since 2018, for a couple years, I was working with it, getting more comfortable with it, and trying to really learn how Flutter works. But I ran into a problem. I noticed there wasn't that many people teaching Flutter online, and a lot of things were hard to find. So I decided to start a YouTube channel and actually teach some of the problems that I ran into so that other people would be able to solve them easier. Since then, my work has been recognized by Google, and I became a Google developer expert for both Flutter and Dart. And on top of that, I've been working as a Flutter developer advocate for over 2 years at a company called Agora. And there we provide video and audio SDKs for Flutter and many other languages. All this can be boiled down to I love Flutter and I love teaching, and that's what we're going to be doing here. Okay, enough about me, and let's get into what this course is about. So in this course, we're going to be diving deep, but don't worry, we're going to do it gradually. And in the end, we're going to have built a core production-ready Twitter clone with validation, authentication, properly managed user state using Riverpod state management that can be updated, and real-time updates from the Twitter feed. And that might sound like a lot, but don't worry, we're going to take it step by step and go gradually. And each major concept is going to have its own demo application. That means we're going to have over 20 demo apps in this course. This course is also designed for people that know at least the basics of Dart, which is the language that Flutter is built in. So if you haven't learned that, there's a great course on Zero to Mastery about it. But also, if you know JavaScript or some other major language, Flutter is very similar, so you should be able to catch up. So first, we're going to start with a very general approach of what Flutter is and why you should use it. And right away, we're going to go under the hood a bit and explore the core concepts of Flutter, which is widgets and the widget tree. These topics are very important to understand, and you'll see as we run into issues throughout the course, a lot of them will actually be solved by understanding these core concepts. Then we're going to move into navigation, and by that I don't mean GPS or anything like that. I mean being able to move from your login screens to your home page, and how you go between different pages within your application. After that, we're going to take inputs from the user using something called forms, and we're going to make sure we validate that these inputs are the right inputs, and we should actually use the data that they give us. And since Flutter can go on all these different screen sizes and everything, we need to cover responsive layouts. We want to make sure our app looks good, whether it's on mobile, whether it's on a website, or whatever type of screen you want to put it on. Next, we're going to cover state management, which is actually one of my favorite topics. Now, we're going to go pretty deep into this concept in the actual lessons, but just a quick overview, state is just data, and basically our applications are just different ways of interacting and seeing data. So it's very important that you have all that data organized, and it's easy to work with while you're developing. And to get this data, we're going to be using a database, specifically Firebase. Firebase is also a Google developed product, so it works very well with Flutter, and both of them go together really nicely. We'll also cover the concepts of animations and how to make your applications more interactive. And there are many other topics we cover in this course to make sure that you have a well-rounded understanding of Flutter. And then we're going to put all these concepts together, and we're going to build our final application, which is a Twitter clone. We're going to allow the user to sign up and sign in, making sure that they enter a valid email, have a long password, make sure our Twitter feed is live updated, make sure we're able to create tweets, change our name, change our profile picture, and have all these things working properly. And the most important part of this is that this will be built with organization of code and state management or data management in mind. So we're going to build it with all the concepts we learned, and all these will help you build an application that is similar to how you would build an application in a real job. So hope you're excited as I am, and let's get into it. So before we start, I wanted to answer the question of why we should use Flutter. And before we even get to that part, I want to answer the question of why we should use a framework at all. So the first thing you might have heard is that Flutter is a framework built on a language called Dart. But why can't we build our applications using Dart? Why do we need to use Flutter at all? And instead of telling you, I thought I would show you. So Dart is just like any other programming language where basically you make the computer do complicated math using words. Now this is a simple Dart program. All this program does is we have a counter, we have a loop. It asks you to either press enter or X to exit. It reads which one you pressed. If you clicked X, it will exit and it will finish running the program. If you clicked enter, it will increment the counter and print it out for you. So the name of this file is dart.dart. I got very creative with it. And we can run this file by doing dart and then the file name. So there we go. We're running it. We click enter, counter 1. We can keep doing that. The counter keeps going up. And as soon as we enter X, it exits. Now here is a similar program except built with Flutter. Notice you can increment this and it counts up a counter. This app is a default app you get whenever you create a Flutter project. So you might see a difference here already, but I want to break it down all the way. So the big difference between having a Flutter application and a Dart application, you saw Dart, you're just running some commands within your prompt. While for a Flutter application, we have this whole UI that we can interact with. Now technically, you could do all of this with Dart. You could make a window that pops up. You can make the window resizable. You can make it have buttons. You can even do this little shadow thing over here for all the buttons. But all this code over here was just to create a little counter, just to make a piece of text show up on our computer. I hope you can imagine how much code it would take to make an actual application with buttons and numbers and shadows. So Dart is just that complicated math. And if you were using that code, you would have to somehow communicate with the computer that you want to create a resizable window and that you want each of those pixels to be one specific color. At the same time, you want these colors to be different color. And when you hover it, you want it to turn to an even different color. And I can't even imagine how difficult it is to make a shadow like this. But it is possible with Dart. And that's what Flutter did. So Flutter used that Dart language to write this complicated code that takes all those pixels and everything you have to take care of when trying to create this little button into just a simple widget called the floating action button widget. So using this line of code right here, you get all the functionality you would of creating a whole button from scratch with Dart, except it's just a lot easier to use. So that's why we would use a framework like Flutter instead of just writing in a native language. We discussed why we need Flutter instead of just Dart, but Flutter isn't the only framework. What sets Flutter apart from all the other framework solutions out there? To explain this, we'll walk through the value proposition statement on the flutter.dev homepage, and this is what it looks like. So we're going to go piece by piece about this. So first, Flutter is open source. And we already know that it's a framework. We covered why that is. And it's an open source framework by Google. So what does that mean? So that means if you go to GitHub, you can find the repository called Flutter/Flutter. You can actually look at the Flutter code in here. So the Flutter framework is out there fully for you to see how the code works and how it was implemented. And you can even look at the contributors, and you'll notice that the contributors are software engineers at Google. Now, being an open source project means if you're having an issue with the framework, you can definitely log this issue. And you can even work on the framework itself, maybe even fix the issue by yourself if you know how to do it. It means you can actually go into all the Flutter code. You can go to the library and you can see, for example, the code that's written for animations. And you can actually find out exactly how it works and make changes for it to work better for you. Now, that's a lot easier said than done. This is a lot of code and it's complicated, but it's nice that it's public and anybody in the world can be working on this and making it better. So next, Flutter is also natively compiled. If we go back to the previous example that we had of the demo application, you could see in the Explorer window showing all the folders. There's folders for Windows, Web, macOS, Linux, iOS, and Android. So when you create your Flutter application, your code runs through these folders to make it set up for that specific platform, and you get code that is native to that platform. So multi-platform means you can compile the same code to all of those platforms at once. So it's not like you're writing Flutter code and you can only compile it to Android. You get all those platforms that we showed off at the same time. And it's all from a single code base. So there are some other frameworks that do some of these things. For example, there's other frameworks that are open source, but they might only be able to make websites. There's even some multi-platform frameworks out there, but they might not be supported by Google, or they might not be natively compiling. So Flutter is the one that does all of those things right out of the box. And if that's not enough, Flutter does some more things. So you can hot reload in Flutter, which means you can see your code changes happen almost instantaneously as you save them. It's also very flexible unless you control every pixel on the screen. And kind of the last point we mentioned already, it compiles to the native language, so it's very fast. Now this last slide, you don't have to memorize it all. It's just a high-level overview of how Flutter works. So at the very top, you have the Flutter framework itself. This is what you would be interacting with as you write your Flutter code. This uses widgets to create the user interface and everything the user will be dealing with. But this framework is just the top level. Right under it is the Flutter engine. This takes care of the background tasks that it actually takes to run software. So things like rendering and frame scheduling and pipelining, all of these are handled by the Flutter engine. And the last step is making these applications work for all the different platforms that we have. So every device from the different manufacturers, whether it's from Apple or Android or some other device manufacturer, they have their own custom ways of doing things. So you need to make sure you have it in better that lets you make those custom connections to make everything work how it's supposed to. Now, before we start learning, we're going to need to install Flutter on our machine, as well as some of the other tools that we'll be building with. Now, there's something that I wanted to mention right away because it's something important that you should know. If you want to develop apps for the iOS App Store, you will kind of need a Mac computer. Notice that I said kind of. There are ways around it. You can connect to a virtual Mac computer. There's even some services like CodeMagic that allow you to do that. So it is possible and there are ways around it. It's just a little bit more challenging. And this is for that very specific case of owning a Windows computer but wanting to make iOS apps. You can still definitely build and release Flutter apps to other platforms like Android, and since it's all the same code base, it's the same code. So if you have Windows, don't be discouraged. You're still building the same applications, just test it and run it on your Android app. And then when you're ready to release it to iOS App Store, maybe you can borrow someone's computer or use a virtual Mac. I added some links below to guide you if this is your situation. Now, having a Mac, it allows you to release apps to both Android and the iOS store. And that is the device I have, so we're going to be installing on my Mac computer, and I'll also add some links below to some other platforms if you need help with that. So hopefully this first thing won't come as too big of a surprise, but we're going to need to install Flutter. And since we're going to be building apps for both the Android and the iOS store, we're going to need to install Android Studio. And for the iOS part, we're going to need to install Xcode. Now we need both of these because they have the underlying architecture to help you debug and build these iOS and Android applications. And in general, the connections from Flutter to the specific platform. And you can even use Android Studio to write your Flutter application code directly in there. But I personally prefer VSCode, so we're going to be installing that as well. The reason I like VSCode is because it uses less resources on your computer. It's a little more lightweight, and you can make it look a little pretty. So these are the tools we're going to need to install. Now let's get to putting them onto our machine. First step to using Flutter is to actually install it. So if you go to flutter.dev, hover over docs, you'll see install Flutter as the main documentation. As I'm on a Mac, I'm going to click Mac OS. Now note here that if you're on an Apple Silicon Mac, you might have to run this command, and then you can install Flutter. So to install it, you just click it. It'll go into your downloads folder. Now this next part's important. So you see here's the actual download. Now you want to move it into a specific folder that you won't forget where it is. We need to remember the file path of this. So for me, I'm moving it into a folder called Resources and Support. You can put it wherever you want, but just remember where you put it. Then here, we're going to need to unzip it. And this is my old Flutter install, and I can delete this just to prove to you that this will make Flutter work. So then you need to unzip it into the same spot. We double click it. It starts unzipping it. And there we go, we have Flutter installed. So now you can delete this old zip file. And now we can go into the terminal and check if it's working. So after we unzipped it, we need to tell our terminal where that path for our Flutter is. So we can copy this command. Let's add it into our terminal. And then remember, we need to tell it where our path name is. So we can take this. If you do get info for that specific folder, it'll tell you exactly where it is. You can copy as path name and go back to here. If we set the path to right there, users, resources, support folder, and then flutter.bin. Now if we run it, should work. Now we can type in Flutter Doctor, and Flutter Doctor is a command that kind of tells you how your whole install of Flutter and if you have all the resources for Flutter. So we can run this command. You'll see everything should work. So for me, it's saying it found some potential overlapping files. That's because, like you saw, we just deleted it, so there's a cache of other files. Yours will hopefully not look like this. But even if it does, you see everything completed fine and looks like it's working well. But here's one more thing that I think we need to do before we move on. So now if we close this terminal and reopen a new terminal, and we try to run the Flutter Doctor command again, you'll see it says this not found. Now that's because when we copy pasted this file path right here and we added it into our terminal, it was only for that terminal session. So what we want to do is make it so every time we open a terminal, it knows exactly where that path is. Now to do that, we have to go back to our terminal. If you do the command ls-la, it will show you all the files at the root of your Mac. If you run this, you can scroll up and you should see a .zshrc file. Now this file, we need to edit and add our path name so that every time we run a terminal, it'll remember it. So to do that, we do vim.zshrc and it'll open this file. Now I have some other things in here for other like Python and Python's installer. So you might need to do this for other languages that you work with. But for Flutter specifically, we're going to copy paste this path again. And in order to import it, we need to click the letter I to insert. And then I can do an enter and do Command V to paste it in there. Now again, we need to make sure we get that file path. So we can update that file path to the file path we need. And now to leave this little editor, we need to click Escape. And then :WQ and click Enter. So there we go. Our file path got edited. And hopefully now we can close this terminal, open a brand new one, and we should be able to run the Flutter Doctor command and everything should work. There we go. So now you see I have all these green check marks because everything else is installed. But if you have some red X's here that are not installed, don't worry. We're going to walk through that in the very next lesson. So we are going to be building applications for both Android and iOS. In order to build for those specific platforms, in order for your code to compile to those platforms, you will need to install the underlying tooling for each of those platforms. So for iOS, it is called Xcode. Xcode is the tool that you need. Make sure you click download and download it. And for Android, you need to install Android Studio. To do that, we click download. You make sure you read all the agreements and everything. And for me, I need the one with the Apple chip. So you click it and that'll start downloading for you. Now Xcode you won't need to use too often. It's actually mostly just for the underlying tooling that you have underneath. In the next lesson, we're going to create an iPhone emulator. So we're going to use it there a little bit. But in general, you won't need to use it too much. Android Studio, however, you definitely will. So once you have it downloaded, make sure you open it up and then it'll have you drag it into the applications folder. And there's really not much installing anymore. We can go to the applications folder. We can open up Android Studio. And you should see a screen like this. So there's not really much installing. And you might have to click next a couple times if it's the very first time you installed it. I tried to delete it, but it seemed like it loaded right back up. But at this point, we can create our Flutter project. So we click Create New Flutter Project. Make sure Flutter is selected here. We have our route to where Flutter is located. Click Next. We can give a name to our Flutter project. I'll call it Demo. And there we go. This is our Flutter application. Now, this can be enough, and you can actually use this to work with Flutter all the time. But I personally prefer VSCode. I think it looks nicer, and we're going to install it in the next lesson. Now, last thing we will install is VSCode, which is Visual Studio Code. Everyone refers it to VSCode. Now, this one is definitely more of a want and not a need. There are a lot of Flutter developers that just develop in Android Studio. I just personally think Visual Studio looks pretty and it takes up a little bit less RAM and memory on your computer. So to install it, just Google VS Code or Visual Studio Code, go to the download and download whichever version you need. Then go into your downloads folder, open it up, and you'll have Visual Studio Code installed. Now your setup might look a little bit different, might have different colors. You can customize it however you want. That's part of the reason why I like VS Code. Or you don't need to customize it at all and just leave it. But there's one customization that you definitely need. If you go over here to the Extensions tab, search for Flutter, and you'll see this. Make sure to install this, and this will install both Flutter and Dart to your VS Code so you can write Flutter applications. And this is the same project that we saw open in Android Studio, but now here it's within VS Code. Now, whichever way you choose, whether to go with VS Code or Android Studio, they will all have the same functionality, and you should be able to do pretty much the same thing on both. In this lesson, we're going to set up emulators for both Android and iOS. Now for iOS, it's pretty straightforward. Just copy this command, open-a and simulator. So we put that into our terminal. Hopefully we'll have an iPhone pop up. This one is an iPhone 14 Pro Max. If you want to switch which device you're running, go to File, Open Simulator, and select whichever device. But for this one, we'll just use the iPhone 14 Pro Max. I like the little pill shape here. Now for the Android emulator, we're going to want to open up Android Studio that we installed in the last lesson. We'll open up the Virtual Device Manager, and we'll create a new virtual device. So for this one, choose whichever one you want. I'll just choose a Pixel 5, for example. It doesn't really matter which version you have, as long as your Flutter app is allowed on that version. But for this, we're just going to keep it on version 32. And then we'll click Finish. Now we can run this virtual device. And there we go. We both have a Pixel 5 and an iPhone 14 running virtually, and we can work with it and start building our Flutter apps. So as we've been going through this course, you might be wondering how I got my VS Code to look and act how it does. Well, that's why I really like VS Code, because you can customize it so much. And the way you do that is by going through and adding some extensions. So I thought I'd walk through all these extensions and show you how I got my VS Code looking and acting like this. Now we're going to skip a lot of them because they're not related to Flutter or my VS Code development whatsoever. For example, this Astro one is for developing websites. C# is also not really related. C# is just a different language. And there's many other of these that don't really matter here, but I will go over the ones that do matter. So first one is community material theme. That is the theme that I use for VSCode. This is what the community material theme is. It comes with a couple of different ones. So for example, there is a community material theme high contrast that looks like this. This is the base community material theme, and then there's the lighter one that I do sometimes use. But this one kind of burns your eyes, so I don't use it that often. This is my favorite one. Then there's the copy widget. And this one, while I was preparing for this lesson, I actually forgot that I actually have, and it's very useful. So by clicking Alt-W, it auto selects the widget for you. So let's say we are within this theme data widget, and we want to select this whole theme data. Instead of having to go like this every time, we'll just click anywhere inside it and say Alt or Option W, and it selects the whole widget for us. Now we can remove it if we want, or we can copy it, do whatever we want with this whole widget. Very useful extension. This next one is straightforward. It's just the Dart. There's going to be a Flutter one down here as well, so that one's Flutter. Then we have Dart Data Class Generator. This one I brought up in the course, but whenever you're generating a data class, for example, this to-do one, if you click Command period, it pops up all these things you could add. So you could generate a whole data class for it, which adds in functions like copy with, to map, from map. So you can convert your data from a map to a map. You can create a new instance of this object with the previous values plus whatever you pass in, and a bunch of other ones in there. The next one is Firebase. So this one just adds in some syntax highlighting and helps you write out things related to Firebase. But you can look at the example here. It just gives you some syntax, makes it easier to write Firebase related things. Then you have Firebase Explorer. So this is an extension down here you can go to. You connect your account and you see all of your Firebase projects. For example, we had the Twitter one. We see our tweets here. We go into our tweets collection, which has a tweets document. And here we have my first tweet. Now, if we were in the code and we're updating this, you can refresh. I'll refresh it and show you the updated tweet. For some reason, I still stick to using the web version, maybe because I like it being on a separate window and everything. But this is very cool that you could do it all within VSCode. So the next one was Flutter. And after that, we have Flutter Riverpod snippets. This makes it so you could add in providers a lot easier within Riverpod, or even consumers, stateless consumers, stateful consumers, all these Riverpod related things. You have little shortcuts that pop in and fill out the rest of the code that you need. Then I have GitHub Copilot, which is your AI pair programmer. This is what this little icon down here means. So you can activate it and deactivate it. Basically, AI that helps you write code. It finishes the code line for you. If you're writing a comment, actually asking it to generate a whole line of code like here. So get the Goodreads key from environment. If it's there, bail, so right there. Writes out the code for you without you even needing to write it. Now the reason it's deactivated and has been deactivated for most of this course, although it is cool, it doesn't work fantastic for Flutter and Dart. Another thing I realized, it sometimes writes out the code and you might not understand it and sometimes ends up confusing me more than helping me. But I do use it from time to time, especially when writing JavaScript or doing some web-based programming. Next one is Image Preview. It's just a cute little one that shows you the image in your little taskbar over here. So you know if you import it right, you should see it right there. Just a nice to have. Then you have JavaScript and TypeScript. Jupyter is to do with Python, so we're going to skip all of those. Then you have Live Server, which is also web development, where you could launch a website quickly to the right as you're working with it. LiveShare is pretty cool. So LiveShare lets you pair program with people. You can start a LiveShare session, send a link to your friends, and you can both jump into VS Code and be editing together. Let's see if they showcase it here. You can see participants join in, and you can see what line there are, and you'll actually be able to see their cursor live and changing things directly in front of you. It's very cool. Then I have Markdown All-in-One. This is an all-in-one solution to make it easier to write Markdown files. So usually the readmes here do Markdown, and you can see you have this little highlighting, so it gives you the syntax. This changes to yellow and puts a little icon here that this is a link. If you have a table, for example, in Markdown, let's say we have table, and then another one. And you set up a table to look like this in Markdown. So it's just a specific syntax. Say, hey, and then you put in whatever. And once you save it, you'll see it'll adjust to here to make it line up nicely. It's just easier to work with. It's a nice all-in-one solution for writing Markdown. The next extension, I have Markdown Preview Enhanced. So this is just the default preview that comes, but if I click this, you'll see it's a little bit nicer preview. Maybe if I bring back the table, you see this table highlight like this. You see a table of contents here. Remove it, refresh it, jump to the top. Has little features that make preview a little bit better. And you can customize how the theme of this preview and things like that. All right, per your code formatter is for web, Python, remove comments. So you've probably seen me use this within the course. If you have a bunch of comments in your code, you can run this command and it just removes all the comments. Simple. Svelte is another language for web development, so we're going to skip that. Then we have tab out, which I keep forgetting that I have as well. What tab out lets you do is, let's say you're within here. Normally, you have to go with your arrow key, but tab out lets you click tab and it jumps out of these little brackets. So let's say we're working within this icon theme data. You want to get out of this, so you click tab and you'll jump out and be ready to write the next thing. It's just a quick little shortcut that makes it a little faster. Like I said, I honestly forget that I have it. Don't always use it, but pretty cool. Tailwind is web development, TypeScript web development, Unity, and Unity Tools is for Unity development, of course. If you don't know, Unity is a game development engine. I've worked with it a little bit, not that much, but have the tools in VSCode. And the last one is VSCode icons. If you saw these icons over here, you see a little Dart logo. This is because I have VSCode icons installed. There's a little animation here. Normally it's just like little ticks like that. Then you add in the VSCode icons and you can see they update to look a little bit nicer. So that's how I got my VSCode to act and look like this. So at this point, you should have everything set up and ready to work with Flutter. So to check this, we type in Flutter Doctor, and we should see a whole bunch of green check marks pop up. So that means everything is installed that we need to work with Flutter, and we're actually ready to build the very first Flutter application. We're going to create a directory where we're going to keep all our projects. I'm going to call it 0 to Mastery. 0 to Master, we'll keep it. Let's go into that directory, and here to create our very first project, we do Flutter, create, and then you give your project a name. For this name, I'm just going to call it demo. So that runs a command that creates a brand new project for you with a starter template, and we could see what that looks like by going into that folder and then typing a command called Flutter run. And since we have this iPhone open right here, this Flutter run command will run our project on this iPhone. And voila, there's your very first Flutter application. Now you better get used to seeing this because this is the starter application for basically every Flutter app that you will build. It's a nice, beautiful counter application that counts up the numbers for you, and you can play with it for as long as you want. This app is where all the Flutter magic starts. Let me show you one quick thing to get you excited. Let's open up this file in VS Code. So this is our Flutter project. We're going to go into the main file, and don't worry, we're going to go over all this. I just wanted to show you something cool. But if we update this color to be green, save it. If we go back to our terminal, we can hot reload it with a lowercase r. We'll go over what all of this is, but I just wanted to show you a little bit of magic. We click lowercase r, and just like that, our whole app changes to green. This is called hot reload. We're also going to talk about what hot restart is, but we're going to talk about all this sorcery in the very next lesson. For this one, I want to go over the Flutter structure and where we actually write the Flutter code. Heading back to VS Code, we saw this main file that we updated it. So this file is located within the lib folder. This is where you're going to write all your Flutter code. And usually you'll have some folders in here, so it's a little bit more structured and not just all messy written within the main.dart file. Then we also have a test folder. This is where you write all your tests to test the software using some automations, which we'll cover in one of the later lessons. The rest of these folders are platform specific, so you'll see we have Android, iOS, Linux, macOS, web, and even Windows. Now you won't have to use these folders very much, but there are things that you need to do within them. One big example is adding specific configurations for the platform. We're going to be doing this when we add our database. We're going to need to add network permissions for whatever platforms we're going to be building for. Now, the last important file is this postspec.yaml file. So this file is where you add all your dependencies for your project. Here below, you can see you can add your packages in here. Down below, you can add assets, you can add fonts. Those are going to be the files and folders we're going to be working with. So in this lesson, we got our app running. I showed you a little sneak peek of the Flutter magic, but now let's get into exactly what kind of sorcery this was. But now let's get into what kind of sorcery was happening here when we changed that color so quickly. In the last lesson, I quickly mentioned hot reload and showed you how all we have to do is update some code, save it, do the hot reload, and the changes are reflected in our app almost instantaneously. So that's called hot reload. There's also something called hot restart. Let's dive into both of those and explain how they actually work under the hood. So hot reload, just like the name sounds, reloads the app with new changes that were added. The way Flutter builds out your app and your UI is using something called a widget tree. So you can think of a widget tree like a family tree. But instead of people, you have UI components. Whenever you make some changes, for example, maybe someone gets married, when a hot reload happens, only this section that was affected gets updated within your UI. The rest of the family tree stays exactly the same. During a hot reload, it also preserves the app state. So if we go back to our family tree example, let's say this person's birth year is 1996. If they get married, maybe their name changes, this whole section gets updated, but their state, in this example, their birth year, stays exactly the same. Now, hot restart is where this family tree example falls apart a little bit. But let's say the family tree got burnt up in a house fire, and don't worry, everybody is safe and everyone's all good, but the family tree is completely gone. In a hot restart, you basically restart the whole application from scratch. So even the state isn't maintained. For some reason, let's just pretend their birth year is missing and they have to have a new birth year and everything's a clean slate. Let me showcase this again to you within an application because I think here it will make even more sense. So we have our demo application that we start with. Last time we ran it from the terminal, but this time I'm going to actually run it through VSCode itself. We do this just because it makes it a little bit nicer. So you can do it by clicking this debug icon up here. You can go to this debug section, click run and debug, or you can even click the function key F5. So we're going to start running it. The reason I like to run it from VS Code is because it does a hot reload automatically whenever you save the file. So it just speeds up your development that much more. So here's that same demo application we started with. Now, you remember hot reload does two things. It updates any UI and preserves app state. So our app state here is 0, or is the counter value. So let's put our app state to 5. Now, we go back to VS Code. Let's do the same change. We're going to change the color to green. Like I said, in VS Code, it's really nice because you can just click Save or Command S, and you should see this update right away. So that will be executing a hot reload. See, it updated real quick. App state is preserved. We have the number 5 still here. The app is all green, and everything works great. Makes your development very fast. Now we ran it through VS Code. Up here, we see the icons. If you hover over them, you see this is the hot reload icon. We can click it again. But since there's no changes and it does it automatically on save, I rarely use this. But this circle with the arrow is a hot restart. So hot restart, we can just click it right now. And remember, the state does not get preserved in a hot restart. So this number 5 should get set back to what it was when we started. And if I click it, you'll see the app gets restarted. You don't really notice much, but you see the app state is gone. So that's hot reload and hot restart. Hot reload maintains the state and only updates affected portions of the widget tree. And hot restart is just a complete fresh slate and restarting the application. Now, we mentioned this widget tree. In the next lesson, we're going to explain it and give you a full picture of how Flutter works. Now, whenever we're developing Flutter code, the chances are we're not going to get everything perfectly right the very first time. And although this course is nice and polished, don't think for one second that I didn't have to figure out some issues while I was writing this course. Now in Flutter, and in almost every other language, there's 3 main core concepts of debugging your code. Now debugging just means solving or trying to figure out what the issue within the code is. So the most basic way of debugging code is to add a print statement. We're going to put out a print statement here just to check that if this part runs. Let's say, does this part run? I don't know, you can put whatever text you want in there, but we save it. And now when we go to add, we can bring up this console here, the debug console. If we add a to-do, we can say record this video, add to-do, boom, there you go. Print statement comes out here, says this part is running. So if we were debugging this code, let's say we're getting to this function, we know we're getting here, because we saw that this part does actually print out, so this part ran, so it must be a problem somewhere in here. Obviously our app's working perfectly fine, so we don't actually have a problem here, but if it wasn't, this is how you would do it. So the second biggest way is by setting up breakpoints. If you're using Flutter or whatever other software, you can hover over here, and you'll see you can set a little red dot. We can set a red dot here, here, anywhere. You can set as many red dots as you want. Now what this red dot is, it's called a breakpoint. So let's actually set it here before we actually get to this statement. So what a breakpoint is while your code is running, it gets paused right at this point. And you can see what different things are going on at this specific pause point. So let's go add another to-do item. We'll do record video again. Add to-do, and boom, you see breakpoint get executed. Your line gets highlighted yellow. You see this little arrow over here over our red dot, and our app is frozen in time. So what's going on here? So when we hit our breakpoint, you get to see all the variables and the current data within the application. So specifically, we're working with this to-do list notifier. What can we check here? We can look at the state before it gets changed. So if we open this up, you'll see there's a state right here with 0 items. That means there's currently nothing in our list here. If we set a breakpoint over here after it runs, so we can click play, you'll see now the state has 1 item in it, and it's a to-do item with record video in it. And you might have noticed these play and pause buttons up here. So these other buttons, so you have play, which continues the execution. You have step over, which steps over the next line. You have step into, which goes into the next function. And you have step out, which goes out of this function. So I usually just click play, and let's say I want to figure out what it is at a different point in the app. I would just set it to that other point. So let's say maybe we want it here. I click play, the app's working, and then I go to delete. Boom, I get another breakpoint here. So at this breakpoint, you'll see our state is still at 1 because it hasn't executed the whole deleting part yet. So that's how you use breakpoints. You set these little spots in the code where you want your application pause, where you can see what kind of data it has and what kind of data it doesn't have. But you also get something else. You get this thing called a call stack. So call stack is very useful to try to figure out how we got to this point. Let's see if we can expand that some more. Our call stack sometimes is useful to try to figure out how we got to this situation or what path we took to get to this part. So if we click on it, you'll see we're in the to-do, delete to-do function, which is perfectly fine. How we got there? We got there from the My Home page. Now this obviously is a simple example of this. We know that we had this action over here that calls delete to do, and from this we jump into our function, and that's how we got there. This on pressed is actually handled within the custom slidable action handle tap function. So this is from the actual package we're using. Usually you don't really need to go that deep because the package is hopefully tested and it's a good package, or something within Flutter which is also tested, so you don't really need to go that deep. But if you have one function calling another function, calling another function, calling another function, then you can go into the call stack and figure out exactly how we got to this point of our execution stack. So yeah, breakpoints are very useful. You can pause the code, see how we got there, and whenever you get an error, it actually gives you a call stack as well, so you can go through the code, see how the heck you got to that error part. And those are the key tools of debugging an application. In Flutter, there is a saying that everything is a widget. And to go a little deeper, your whole application is basically just a widget tree. Now this topic is so important to understand in Flutter, and I think the best way to showcase this is to go through an example. So this is a simple and common widget you might see within your applications. Now this widget is composed of many widgets within it in a structured way called a widget tree. You can look through all of these and they're highlighted what each specific widget is. If we break this down into a widget tree, we can get more clarity on what's going on here. So we have a container, this whole thing. Then we have a row, which is one row right here, with 3 columns, this column, and this column. Each one has an icon and a container with a text in it. So this is a very simple widget tree using some very simple widgets. But of course, your whole application, this widget tree could get a lot more complicated. If you go to flutter.dev, go to documentation, down here you can see there's a widget index. This is nearly every widget that is bundled within Flutter. And if you scroll through all these widgets can be within your widget tree and actually build out a whole application for you. Now let's go even deeper. But on the left here, you see this is the code that we use for the counter application. We're going to walk through the whole application and build out what the widget tree would look like for this demo application. So on our main file right here, we have this thing called run app. This is your entry point for every application. And the very first widget we see is my app. So this my app widget is at the very top of our widget tree. And notice these things called stateless widget and stateful widget. We don't need to worry about it here, but in the very next lesson, we cover what they are and why we need to use them. For this lesson, all we're going to need to look at is this build method. The build method returns the UI and all the build elements that build out the rest of the widget tree. In this build method, we find the very next widget within our widget tree, and it's called material app. Now, material app has some properties in it that we don't really need to worry about. It also has this home property, which shows us the very next widget within our widget tree. So it's the My Home Page widget. Now we can find the My Home Page widget right here. And like I said, we don't need to worry about all this stuff right now. We just need to worry about this build method. I will notice the next widget within our widget tree is the scaffold widget. And the scaffold widget actually breaks down into 3 other widgets: the app bar widget, the center widget, and the floating action button widget. Now I can go through each of these. You see the app bar has a text, the floating action button has an icon, and the center has a column widget. And then lastly, within that column widget, we have 2 text widgets. So here we go. This is our widget tree for that base application that we have built. Now, how do we know that I'm not lying about this whole widget tree concept? Well, we can go back to our code. And if you click Command P or Control P if you're on Windows, you can type in Open Devtools Widget Inspector page. There's a lesson covering what Devtools are, but for this section, we'll know that Devtools shows us the actual widget tree of our application. And you'll see, it starts with the My App widget, goes to Material App, goes to the Home Page, Scaffold. Scaffold has 3 widgets within it. The app bar has a text, floating action button has an icon. The center widget has a column with 2 texts in it, which is exactly what we had here. So this widget tree is one of the main concepts you need to know in Flutter. Make sure you have a good understanding of this before we move forward. Now next in Flutter, you saw the list of a bunch of widgets, but all of them are based off of 2 widget principles. And that's stateless widget up here and stateful widget. And next lesson, we'll cover what these are. There are 2 types of widgets in Flutter: stateless and stateful widgets. Now you probably heard a keyword in both of those, and that's state. But what is state? State is just data, and to be a little bit more specific, it's data that can be updated or manipulated. Let's take a look at some examples. So here in the Fitbit app, we have a lot of state here, lots of data talking about how many steps, calories, all these things. The app bar, depending on the state of the app bar, which screen it is on. Up here in the top left, there's a little state of the account that you are in. Another example is Twitter. So this follow button, whether it's followed, whether it's clicked, whether it's active, that's a state. The follower numbers, all the information here, that is state. And lastly, the biggest one and easiest to understand, I think, is accounts. So which accounts you're logged in with is a state of the application. So that's state. Like I said, state is just data. It's data that can be updated and manipulated and used within the application to do stuff with the app. And Flutter has two widgets, stateless and then stateful. Stateless widgets. These are widgets that don't hold any state. Maybe it's just a static image that just displays on your screen. Maybe it's text that is displaying. Maybe it's icons that don't really change. And then we have stateful widgets. These are widgets that hold a state. A very clear example of that is a text field. When you're typing in text, that text is your state of the text field. A checkbox is another good example that has two states. It could either be checked or not checked. Now let's jump into our demo app to showcase this in actual Flutter code. So this is a demo app that we've been seeing. This is the counter, you can increment it, and we'll notice the main widget that we have is called My App, and this is a stateless widget. It's stateless because this doesn't hold any state. It just gives us the rest of the application. But the things below it, for example, this homepage widget is actually stateful. It's stateful because it does have state, and that state is a counter. It's this elegant, beautiful counter that we have here that does magical things. This counter is displayed, and our state can be updated using this thing called setState. So we can actually hover and read what it does. It notifies the framework that the internal state of this object has changed. The state that we're changing is we're incrementing that counter. Whenever we wrap it in a set state, we're telling our stateful widget that we want to rebuild this build method. Let me showcase something for you. So in VS Code, let's hover over the stateless part of it. This text. This text does not change. This is stateless. We can, if you click Control period, you can see this window pop up. And let's click Extract Widget. We can call this stateless text. Okay. So we have two widgets within there. We have the stateless text widget, and we have this text that is within a stateful widget that gets updated. So our text is stateless, and we can add a breakpoint here. What this breakpoint does is it tells you if this line of code ever runs. So when we refresh, of course, it has to run, and we see a big yellow stoppage point right here. It means this point got executed. And whenever we restart it, of course, it has to get executed because we have to display it. And then the UI is updated. But you'll notice whenever we click the plus icon, we're changing the count. Our stateless widget doesn't get touched because it doesn't have any state. Let's go back to our stateful widget. So this is the one actually holding the counter. We put a breakpoint here where the counter is, and you can put it anywhere within this build method. This whole thing gets rerun every time the state changes. Now if we increment the counter, you'll see this breakpoint gets executed, and we know that this line of code runs every time we click that button. Now within stateful widgets, we have access to some functions that allow us to execute logic either before or after the widget gets built. So specifically, there is init state. If we hover over it, init state gets called whenever this object is inserted into the widget tree. So before we actually see anything happen here, this function runs. And I can prove that to you because we can set the counter to 10 here. And we can remove all those. So if we refresh now, restart the app, you'll see the counter starts at 10. And I didn't even see the 0 or anything like that because the init state executed before we even had a chance to build any UI out. There's another one called dispose. So this runs whenever the object is being removed from the tree permanently. So in this case, we're not really removing anything, but let's say we went to a different screen and we're coming back from that screen, we would run the dispose method if we needed to dispose anything. We'll be using the init state and dispose method later in the course whenever we deal with animations. So we covered what stateful and stateless widgets are and when and why you should use them. Now we're going to go over some of the most common ones to help you get acquainted with Flutter and widgets. In the previous couple lessons, we talked about the widget tree and stateless and stateful widgets. Now in this lesson, I want to go through a bunch of the widgets and give you a little feel of how it is to work with the widgets in Flutter. Now if you remember, everything in Flutter is a widget, and all the widgets in Flutter are derived from two widgets, stateless and stateful widgets. Now in total, there are hundreds of these widgets. And we're going to show you a couple, but please don't get overwhelmed. You don't have to memorize these. So to get a full list of the widgets, if you go to flutter.dev website, click on Docs, and bottom left here, you click the widgets index. You'll get a huge list of all the widgets within Flutter. Now this might look a little bit overwhelming, but don't worry, you do not have to memorize all these. I know that I definitely haven't. There are widgets in here that you'll use a lot more than other widgets per se, and those you'll probably start memorizing, and the more you use the widgets, the more easier they'll be to work with. So Flutter is pretty good at naming widgets, and I recommend you search for the type of thing you're trying to do. So let's say we want a button. We can search for it, and we see there's Cupertino buttons, elevated button, drop-down button, all these different types of buttons. Let's say you want one of those switch icons where you could turn on settings. Type in switch, you'll see Cupertino switch, and you'll see the regular switch. And a nice thing about this widget index is they have pretty cool little images here that give you a feel for what this widget does. Now you can search for widgets, or if you don't know what to search for, you could even just look through all these widgets. And again, you do not have to remember a lot of these. The more you work with them, the more you'll be able to pick them up. Now for the rest of this lesson, I want to go through the default application that you get with your Flutter app and explain every widget that is within there and how I go through understanding code and how I work with it. And in the next lesson, we're going to take 5 to 10 widgets and just work with them, get a feel for how widgets work, and build some goofy looking page. So this is the default application you get when you do a Flutter create. Now the first widget is a widget that we have to define ourselves. This isn't a Flutter defined widget. You'll see we could change the name to Tadas app, and everything works perfectly fine. This is just an entry point for our complete Flutter application. And the first Flutter defined widget is called Material App. Now, if there's a widget that I don't understand within Flutter, I like to hover over it because there's always a good description here. So you can read this description, but I'm just going to explain to you Material App real quick. So Material is a design language that Android uses for its Android applications. You can actually go to the Material Design website, and you can click on styles, and they can show you all the different styles that Material App should use and how you should style an app to make it look like the Material application. So Flutter comes with the actual widget that makes your apps look like Android apps. There's also Cupertino app, which makes your app look like an iOS app. Now this Material app provides some base features. So first we have something called a Navigator key that basically used to move between pages within your application. You have things like theme, where you get set what colors your application uses. And then there's even things like debug features. So I can showcase that for you. You see this little red icon called debug. We could do show debug check mode banner to false. We save it and rerun it. You'll see that debug banner is gone. And within the Material application, we have to define our home page. So this home page is very clearly named my home page, and it is a stateful widget. It's stateful because we're going to have a state of the counter that we're going to be incrementing here. And now within the stateful widget, we have a scaffold, which is a very key widget within a Flutter application. So scaffolding is just like scaffolding construction. It's a support structure for your UI. Now let's say if we remove the scaffolding and maybe just do a text like hello. If we save it, you'll see our app looks completely messed up. There's no background. There's nothing for our text to be sitting on it. The text is just on nothing. And that's indicated to you by this red and is underlined. You know you did something wrong here. So we'll bring the scaffold back, save it, and these other widgets we'll go through in the next lesson. So in this lesson, we're just going to plow through a bunch of different widgets. Now we're going to start off with the widgets within the scaffold. So the scaffold has some arguments that you could pass into it. Now, the way I find out what arguments a widget has or which ones I kind of need to use, I like to hover over them. For example, in this one, the scaffold, I could look into all the arguments that it has, try to understand it. If I don't understand it from this documentation, you can always go to the flutter.dev website and you can look into it deeper there. So within the scaffold, you can define an app bar. Now, this app bar widget is this blue bar up at the top. If you remove the app bar widget, we'll notice it goes away. I'll bring that back. Now in the app bar, you again have a bunch of different customizations you could have. Like you can change the background color, you can center the title, because on Android it's normally not centered, and a bunch of other behaviors that you could find if you need to use them within the app bar. But I like how this looks. Another field within the scaffold is a floating action button. So the thing that's special about the floating action button is that it's above this back screen over here. It's named the floating action button because it's floating above everything else. You can have all your content, maybe like a Twitter application or something. You have all the posts over here. This will always be floated above so that you can click it whenever you need to. In this case, it just increments our counter. Now we get into this middle section. So this is the main portion of the app. This is where everything is going on. So our center widget centers all our content in the middle. If we removed it and that is still centered, because the column expands from the very top to the very bottom. And we can actually see that if I wrap it into a color. So there you go. This is what your column widget looks like. The column goes all the way from the top to here. And this main axis alignment, so the main axis for the column is going up and down. You want that to be centered. And let's just keep the container and bring back our center widget. If we save this, you'll see now it's centered vertically and horizontally. Let's remove this little color. So then within our column widget, a column is like it sounds. There's both rows and column widgets within Flutter. A column means you can put stuff vertically on top of each other, just like this. I copy pasted this text, and you see it's all on top of one another like a hamburger. And these text widgets are also pretty straightforward. It's just a piece of text. And you can style it to make it look bigger like this 3 is. Now, I just want to mess around and show you a couple other widgets. So let's say we want a list of text. We could go to the Flutter index and then search for list. It's animated list. We're not trying to animate anything. There's a column, which is a layout of list of children, which is good. There is also a list, more specifically a list view, a scrollable linear list of widgets. So let's try using a list view, see what that looks like. Now this is the list I defined, and let's change this to Andre. But as I saved it and I try to load it in, we got a problem. The problem says our viewport does not have a has size. Let's see if we can find the original problem. So vertical viewport was given an unbounded height. Now feel free to pause and read this description. It will explain the error even better for you. But what it's saying is that we have a column, and remember, column was all the way from the top to the bottom. And then we have a list view, which is within that column, and you're not really telling the list view how tall it can be. And then the list view is within that column. Now, list view wants to do the same thing. It wants to go from the top to the bottom. But since it's within a column and there's other stuff in there, it doesn't know how to do it. The solution to that is to give it a size. We could just tell it. Let's say we want it to be a height of 200. So there you go. Now you see everything is in a list view. And notice we wrap this thing within a sized box. So what is a sized box? If you read the description, it creates a fixed sized box. It allows you to basically give a height and a width of what you need. And it's actually a pretty commonly used widget because let's say you want some space between this text and the counter. You can add a size box here. Let's just do 100 to exaggerate it. A height of 100, you'll see there'll be a big space in between these two widgets. So you can use the size box widget to do things like that. But the most common widget is called a container widget. Now, a container widget is like a size box, but it comes with a lot of other properties. One of those is color. We've done this before, but I didn't explain it. By using a container, you could set this property of colors.red. Now let's actually remove this and just put it at the top because it doesn't really matter. It doesn't look good with white above it. Now, the container is also one of the most commonly used widgets. You usually use a container when you can't find a widget that does what you want, because a container can be fully customized. And let me change this color from a red to a light blue so we could easily see the text. So let's highlight over the container widget and see what other properties we could give it. We give it things like padding and then things like margin as well. So let's give it some margin. To give margin, you do edgeinstance.all and then give a value of how much pixels of margin you want to give it. If we save it, you'll see now there's a little bit of margin around our whole container widget. You could also add some decoration to this. So here you see you could give this little container a border. And we can make it as wide as we want, even make it like 10 wide. Now this doesn't look good because our text and everything is getting cut off by the border. And this is easy again to fix within a container using some padding. If we do 20 padding all around, you'll see it gets brought up into the middle. Now the container widget, like I said, will probably be working a lot within Flutter as it's used to do little designs like this, putting borders, adding padding, and adding some margin to other widgets. So we covered the list view, but there's also a page view widget. Page view is the same exact thing, except for everything being in a list. Actually, let's go back to the list view. I didn't show you that this list is scrollable. So let's say we had a bunch of things in here. You'll be able to scroll through these like a normal list. So now let's turn this into a page view. Page view is a very similar concept to list, except it's pages. So you can scroll through the pages and through all the different entries within the page. These are just some of the widgets you would use within Flutter. The next lesson, we're going to do a little test. I'm going to have a UI that I would like you to try to build out yourself, and we're going to go through it, and I'm going to show you how I would build it out. Okay, so the page I want you to try to build out is a settings page. Now this is, of course, not the most beautiful page, but we're just trying to get a feel for what the widgets are. So see, we have an image at the top. We have a place to enter text in. We have a switch like this and a button, all centered and vertical. Now for the picture, you could use this link over here. This gives you a random picture, a size 200 and 200, and trying to figure out how to make that picture show up in your Flutter application. So I encourage you to pause the video here, try to build this yourself, just to get a feel for how to search for widgets and how to figure out what you need, and then we'll go through it together. So we're going to start from a clean slate. The very first thing that we did a couple times already is trying to figure out this top part over here. This is an app bar within a scaffold. So we know the scaffold has an app bar property, and we can give it an app bar. Now, the text I had was called settings. If we hover over app bar, we see it has something called a title. Let's test that out. And we'll see that title, if we hover over it, needs to be a type of widget. So text is a type of widget, and we can change this to be settings. So we save it. There we go. That's the first part. Now, the next thing I notice here is as we're looking at the application, there's multiple things all in a row vertically. So to do this before, we've done it using a column widget. And let me just test that using a widget that I know already, called a text widget. Let me copy paste that twice and see what that looks like. So there we go. Two widgets, both on top of each other. But one problem is those widgets are not in the middle. I need to make sure they are horizontally centered. So when I look at the column, I see the main axis alignment. I encourage you, while you're working with Flutter, just keep trying stuff. It comes with hot reload. It's really easy to test, see whether something is right or whether it's wrong, and it'll give you a good feel for how it works. We do main axis alignment dot center. We save it. That's not really what we wanted. We didn't want it in the middle of the screen. We want it to be centered horizontally. Now there's also cross-axis alignment, but you see here, it defaults to center. So that can't be the reason. Now whether you go this hard with debugging, that's up to you, but I just wanted to show you something that if we give a color to the background, colors.red, we'll see the cross-axis alignment is technically centered. The problem is that our column is only this wide. So in order to have it centered horizontally within this red box, your only option is to put it here. So our other option is using something we called before. It's called center. We save it here. That puts it in the center, and we can actually remove this main axis alignment because we want it to just be at the top. Now let's do one step at a time. So this next thing is an image. Now you can check the documentation. You could search for anything related to images, or sometimes I just even like to guess. So if we do image, if we scroll down, you'll see there's image.asset, image.memory, and image.network. So since we are using a URL, we want to use image.network here. And you'll see a bunch of red squiggly lines here because if you hover over it, it says evaluation of the constant expression throws an exception. So an image from the network cannot be constant. That's because image from the network isn't just something static. It is an image that comes from the network and you have to insert it here. So we'll remove that constant, and then within the network, we'll add our URL that I showed you earlier. There we go. Let's try to save it. And it's starting to look something like that. Now the next thing is this field over here. So we can actually go to the widget index and type in text, and we could just scroll through. You see something called a text field here that actually looks like what we're using. So let's try to add that into our application. Text field, we save it. Now we see is just a little underline like this. That's not what we saw in the application that we have to build. So let's hover over text field and see what type of properties it has. So it has a decoration property. That sounds like it could be right because this needs to be decorated to look more like this. So our decoration takes an input decoration, and then our input decoration takes in a couple other fields. We're going to find the fields of border and give it an outline input border and a label text of username. So now, if we save this, it says we have a problem. Have an extra little bracket here. There we go. Now we're typing it in. It looks kind of what we were looking at before. There's one problem. Those are really tight together. There is a little bit of spacing here. Remember in the last lesson, I mentioned that's what you can use size box for. Now we'll give it a height of 20, and that's looking a little bit better. But still, not perfect. You see, this username has a little bit of space around here, while this is all the way up until the edge. It looks like we need to add a little bit of padding between the edge of this wall and the username. So we can wrap the text field in a widget, and you can do that by clicking Command period, and select this wrap with widget option. And actually there is a wrap with padding option available to us right away. So I'll just click that, save it, and now we're looking even better, and it's pretty similar to what we had. Now 2 more widgets to go. We see this notifications widget and this switch. So we can go to the widget index, look for something that's switch related. And there we go. That looks like something that we would need. We'll go back to our application, and we can actually remove this hello now and just start typing switch. So for switch, you're going to need 2 things, a value and an onChange method. So onChange is called whenever the toggle is toggled. And there will be a function that will give you a new value. And then we actually have to give the value of our switch. So that needs to be a variable defined at the top. It needs to be a Boolean. We'll just call it value, And we make sure we put it within the state, not up there. And then whenever it changes, we need to set our old value to the new value. And there we go. It's working perfectly. Again, if we look back at our design, we had this notifications thing. And it looks like it's in a type of row with the switch button. So let's try to wrap this within a row, which is, again, one of the options in the command period. Here we'll do text, and we'll do notifications. That's good, but it's not centered. So for a row, it has a different axis than the column. So for this one, we want to actually do the main axis alignment, and main axis alignment dot center. The very last widget is a button. You go search for buttons in the widget index, but we're just going to do an elevated button with a child that says save and on pressed, and it doesn't do anything because we're just trying to have something that looks nice. So there we go. We built out the starting template. Now you don't need to worry because in the rest of this course, we're going to talk about the different layouts. We're going to cover a lot of different widgets. We're going to get more practice with these specific widgets. And by the end of it, hopefully you'll be a master on widgets and different layouts. So Buildcontext is a little bit of an advanced topic, but it does a relatively simple thing. It's a way for your widget to know where it is located within the widget tree. It gives context about where your widget is. Think about it as if you were blindfolded and dropped off in a random city. You'd use the context around you. You'd look at the street signs. Maybe you'd look at the sun's direction, some landmarks. You'd use the context around you to figure out where you are. Same thing with Buildcontext and Flutter. Now, we're going to get deep into how Flutter works under a hood, but there's a reason Flutter was built as a framework. You don't really need to know this when you're working with it day-to-day. All these things are abstracted within the framework to make it easier for you to develop. If the only thing you remember from this lesson is that Buildcontext gives you context on where your widget is located in the widget tree, you are solid. But I do find it really fun to dig deep into it and kind of understand how things work under the hood, so we're going to dive deep. So I mentioned that everything is a widget before, and that's not the full picture. A widget is basically a blueprint for your app, and this blueprint is used for something called an element tree. This element tree controls the life cycle and tells you about the location of where this element is within the tree. This blueprint is also used for something called a render tree. The render tree is the one that displays the UI of your widget. So your element tree handles the life cycle and figures out the location of where your widget is, and the render tree is the one that actually displays it. This lesson, we're going to focus on the element tree. So this element tree, let's highlight this text, for example, knows where this text widget is. It does that by using the context and going upwards in the widget tree and figuring out that it belongs to this container, then column, row, and this container. One thing to know here is it can only tell where it's located vertically within the element tree. It has no clue about where it is horizontally. So this text widget doesn't know where this text widget is. And like I mentioned, it uses the context in order to gain information about where exactly it is. Some most common ways to use context is with a navigator. So your material app gives you a navigator, and you can use the context to go back up the widget tree to figure out where your navigator is, and then do some navigation based on that. Another very common one is your theme. So you use the context of what this element tree is, and you find the theme associated to this context, and you can use it within your application. Now, in the next lesson, we'll actually go over the navigator and how to navigate through this. But I wanted to finish off this lesson by telling you a little story about Flutter's past. So what we're going to be doing here is displaying a snack bar. Now, we have a very base application with nothing in it, not even the counter, just a little button here in the middle that says snack bar. The way you add a snack bar into your Flutter application is you use something called a scaffold messenger and use the context of this application to find that scaffold messenger. So you get this context from here, and this context belongs to my home page. So using this, it looks up the widget tree and finds that we have a material app here, and this material app has a scaffold messenger. So using this context to find the scaffold messenger, and then you use a function called show snack bar. You define what kind of snack bar you want. The content in there, we're going to say, I'm a snack bar, just in case it wasn't obvious. Okay, now if we save it, we click it, I'm a snack bar pops up at the bottom. Now the story here is that this was done very differently a couple versions of Flutter ago. So a couple versions ago, in order to display a snack bar, you used to do scaffold.of_context. And you used to do show snack bar, which is no longer here as an option. I'll just add it there for the story. So this doesn't work anymore. Why was this changed? So how this worked before is within the scaffold, you had the logic to show this snack bar. So you'd use the context to look up the tree to find a scaffold where this belongs to and show the snack bar there. Now what's the problem here? We mentioned this context belongs to the My Homepage widget. So My Homepage doesn't have a scaffold above it. The scaffold is within this, and we're using the context that's above it in the element tree. Whenever you'd run this, you get an error saying that this context doesn't have a scaffold. Now there was a way around it. You'd use something called a builder widget, and this builder widget has a context within it. So then you'd use that context instead, and this one would look up its widget tree and see there's a scaffold above it, and then it would work. But a lot of people had issues with this, so they updated and made it easier for us, and now we just use a scaffold messenger to show our snack bar. So that's build context and a little story about how it changed a little bit how Flutter works. And we'll be using it a ton when doing navigation, which is what the next section is. Navigation is how you handle new pages and go back to previous pages within your application. We call this routes within a mobile app. And there's two main concepts you need to know when it comes to navigation. It's push and pop. Let's pretend this is you looking down at your screen. Now this is some sort of Android, and you see there's a home page here. The person is looking directly down at it. There's a concept in navigation called a stack. Right now, the stack is only one page deep. So let's say we want this second page to become visible for the user. We push that page on top of the stack. And now the user doesn't see that bottom page, they only see the top page. Now when we're ready to remove it, we do the exact opposite and pop it off of the stack. Now the user can see the main home page again, and the second page is completely gone. Now we're going to cover three types of navigation in Flutter. So there's a very simple navigation, then we're going to do name navigation, and then navigation with data. So let's start with the first one. This is our starter application, except even more simplified. I wiped out everything that we had in here, so we start fresh. Now, in order to navigate somewhere, we need to trigger it in the first place. We're going to do that simply by using a button. And we'll use a text button. This text button has two fields. One of them is the child, so whatever is going to be seen within that text button, and we're just going to put a text in there and call it first page. Now, whenever we press this button, this is where we're going to want to execute our navigation logic. That's what the button looks like, but it doesn't go anywhere. We're actually going to add a second button, so just copy paste that and change it to second page, because there's two different syntaxes that to navigate to, and I want to show off both of them. So these don't do anything. In order to make them do something, the first thing we need is to have an actual page. We're going to add a new file to our lib directory for the first time, and we're going to add it inside a folder to keep things organized. So we're going to have a folder called pages and a file in there called first.dart. If you're using VSCode, you should have installed the Flutter VSCode plugin, and that plugin gives you access to some snippets. So if we type in STL, you'll see there's a Flutter stateless widget snippet, and if we click it, it fills out some of the fields for you. We're going to call this first page. Now remember, The page doesn't really exist without a scaffold because that is the base of our UI. So make sure to add a scaffold, and we'll also add an app bar in there with a title that says first page. Okay, if we try to click it, still nothing happens because we haven't told it to navigate to that first page yet. Let's go back here. We're going to find the Navigator within our widget tree, and we do that by calling of context. Remember, context gives us the location of this widget within the widget tree, and it allows us to look up the widget tree, and in this case, find our material app here, which has a navigator. So we found that navigator, and now we can push a route onto there. Since we are using a material app, this will be a material page route. And we are going to push our first page. Okay, so that's the logic in order to navigate to a new page. You should be able to click on it now and go to our first page. And something special that you'll notice is we have a back button here that actually works. But we didn't add anything here. So the app bar automatically comes with a back button if it's not the top page on your stack. But let's actually show off how to do it in case you didn't want to use an app bar, or you want to just be able to trigger it to pop off of the stack manually. So in the body, let's just add another text button here. Child we will call pop. And on pressed, it's actually even easier than the other navigation. You do navigator.ofContext, and you just call the pop method. So we'll save it. You see a button pops up that says pop. If we click it, it does the same exact thing as that back button did. And there you go. You got your first navigation. So why did I add this second page? There's actually two different syntaxes for calling this, and I figured I should show both of them. So let's add a second.dart. Paste that in there. Didn't work. We'll paste that in there. There we go. If you click Command D, it'll select all the words that match the thing you've highlighted. So we can actually type in both of them. We'll do second page. So it types up for both of them. We'll change this to be second page. And now let's go back to our main. I'll actually copy this because the syntax is similar, just a little bit different. So instead of doing navigator.ofContext, you can just do navigator.push. And then do context and put a comma. So the push can take context as a parameter instead of doing the navigator.of. And let's update this to go to the second page. Now there's not really a difference between these two. It's just whatever you prefer, whatever is your favorite way to write it. But you see, it works the exact same way. So that's the basics of navigation and how to push and pop onto a stack. Now let's do the exact same thing except with named routes. So why use anything other than this basic navigation? Well, imagine you just have a bunch of these routes, maybe like 4, 5, 6, 7 throughout your whole application being accessed from different places everywhere. That can become a little hard to manage. So you can use named routes in order to stay a little bit more organized. Now for named routes, you have very similar syntax to what we have here. Actually, to update it, all you have to do, instead of push, you do push named. And instead of material page route, you pass the name of whatever route you want to go to. The convention for routes is for them to start with a slash. Now a slash like this is just the home route. So this is the very main page that your app always starts on. In order to find any other route, you need to put a name for it after the slash. In this part, we're going to get real creative here. We're going to name this route first. Now this syntax is the same thing. We change this push to a push named and replace this route with something more creative. like /second. Now when you go to click on them, you'll see we get some errors. That's because we have not defined these routes anywhere. So the /first and the /second means nothing to our application. We need to define it first. You do that in the material app. So the material app, you'll see it has a routes field. We're going to need to fill this out. So in here, we need to give it a list of our routes. Like I said, the very first home route is just a /. And this will lead us to the home page widget or home page route. So I just define my home page, just like that. You have to remove the constant because when you're adding routes, this app is no longer a constant. Also, we're defining the home page here. This / route is our home page, so we don't need this home field anymore. And then you just go through and define the rest of your routes. So we have /first, and that goes to the first page. And we have /second, and that goes to second page. Now again, I want to cover why did we do this. Let's just keep organized. So you see this string right here, this route is defined once here, and we're able to call it from every single place, and we'll always lead it to this specific page. So it cleans up our code and makes like a source of truth for all the routes that we are using within our application. And that's how you do named routes. Let's see if it works. Click first page, it goes to our first page. We're still able to pop and push all our pages just as normal. Remember, the pop page, we can actually go to that. This pop doesn't have to change because we're not putting in a route. We don't have to specify where we're popping from. It's just a stack. And when this page gets pushed on top of the stack, it's just saying to remove the very top layer of that stack. So that's named routes. It does the same exact thing as normal basic routing, but it just keeps things a little bit more organized by defining them here. Now sometimes you want to pass data between these pages and back from these pages. We're going to get into that in the next lesson. Now sometimes we want to pass data between these pages. Let's say we want this first page to display a person's name, and we want that name to be passed in from this first page. Maybe there's a text field where someone puts it in, and then you click here, and it just shows up here as well. Now we're not going to do all that text field stuff because it's not really necessary in order to showcase the point, but we're just going to pass one name here and another name here and have it show up here. We're going to do it two different ways. First using the basic navigation and then next using the name navigation. So to start off, let's bring this back to the basic navigation that we started with. So we need to pass in our material page route. And have this go to the first page. All right, so when you have a normal navigation where you just push the page route, you're defining the widget right here. So since it's getting defined here, you can just pass a value here, just like this. Now we have a problem here because this name field isn't defined. If we go to our first page, we need to define an entry field here. You do that by first creating a variable where this field can be stored in. So we're going to create a variable named name. I'll make it nullable just to keep our code clean. Now you have the variable defined right there. You need some way to pass it in. To do that, we just do this.named, and it gives a way to pass something to this first page and then assign it to this name right here. If we go back to our main, you see the error goes away. Everything's good. If we go to it, it's not there yet because we haven't actually displayed it, but the data is there. To display, we could just do hello and then interpolate the string. It's no longer a constant. So if we go to the first page, you'll see it shows up at the top, hello and Tadas. That's how you do it with basic navigation. Now, if we do the name navigation, it's a little bit different. See, the nice thing when doing it this way is that you define the actual widget right here. But with named, it is defined all the way up here. And we can't just do something like this because that doesn't really make sense. That means you would, every time you go to this first route, you'd have the same name, but we want to change what type of name it is. Now, problem, like I said, is this route is already defined, so we can't pass it into the widget directly. We have to pass it through the route. Now, to do that, push named also has a field called arguments. Arguments, we're going to put Andre, the name. So if you read this, the provided arguments are passed to the pushed route, and we'll retrieve them from that same route in this other screen. To do that, you do modal route, and then when you need to use that context that we learned about, so it finds the route of this specific context. We need to get the route settings from there, and then the arguments. After that, we have all the data. We can do hello args. Or I guess we could just name it a little bit better. We'll call it name. Okay, so now we go to the second page. Should see hello Andre. Perfect. And now maybe you want to do something on this screen where when you go back to this screen, you want to update it with that data. So we need this pop function to pass data back to the first screen. To do that, you can just pass whatever data you want into the pop method. This is from the second screen. In our main function, we just assign this as a return value from our push name function. And since this is a future, we want to make sure to await it. And for here, we're just going to print the response. So if we go into the second page, we see hello Andre getting passed from the first screen. And if we click pop, you'll see this is from the second screen message pop up down here. Now, when I see this, it looks a little bit messy. There's just a lot of things getting passed here and back, and I feel like if you have a really big application with a lot of routes, these things could be kind of hard to manage. Well, in a future lesson, we'll see why you don't actually use this that much, at least in bigger applications. If you're building a smaller scale application, or maybe something with not a lot of routes, it's okay to pass data like this because it's just simple. But as your application scales up, becomes bigger, that's going to be messy. And the way you don't use something like this, the way you don't do this too often, is using something called the state management. Remember, we learned about state, so this name we're passing in is technically a state, and we're just passing it between these screens. There's a whole topic we're going to cover later in this course about state management that keeps things a little bit more organized, and you don't really use this too often. But I wanted to let you know, so we cover all the things that navigation does, and we managed to cover basic navigation, name navigation, and how to pass data between the navigation. So that's it for navigation. So I wanted to give you some insight on Navigator 2.0, just in case you see this word flying around anywhere. So since there is a Navigator 2.0, there must have been a 1.0, right? So let's cover what that is first. So Navigator 1.0 is the thing we actually already covered in this course. It's the stack of screens that you can see, and you can interact with it in a couple ways. I'll cover them using the same slides as I did before. You can push and pop things onto that stack. So let's say you have a home screen. You want to see another screen. You can push that on top of it, and now you have your stack of two screens, and you see the top one. If you want to go backwards, you just pop it off, and then you see the home screen again. So that's great, but what's the problem with this? Well, there's a couple issues. Firstly, you don't have full control of that stack. So if we go back to this previous example, let's say you have a stack of like 10 of them, and you want to remove this sixth thing within this stack. You don't really have access with the Navigator 1.0 way, which is what we covered. And then there's a a pretty complicated use case that isn't used that often unless you have a very complicated application with a complicated navigation. So the other thing is similar story. For a very complicated navigation application, you might want something like nested navigation. So that means you have, within the whole navigation of your application, you have another sub-navigation section where you can navigate between screens within there too. That's also something that you can't really achieve with the 1.0 Navigator that we used already. Now, last one is a big one though. With the original Navigator, the web support was lacking. So first, the back button didn't really work that well. And second, so if you went to a sub-page, so if you had a URL / some sort of other page within your application, that didn't work too well either. So to fix these issues, the Flutter team came up with Navigator 2.0. And the story behind this is when it came out, people struggled to implement it or struggled to understand it quickly. Now, maybe this doesn't look too bad to you, but it is a little bit complicated. Where you have your actual operating system, when you want to do a new route, you have to go through route name provider, route name parser, and then router delegate is the one that actually controls all the route logic. And you also have a backbone dispatcher that goes into this as well. And this router delegate specifically controls all the actions within the routes. Now, if you're writing your own navigation using Navigator 2.0, you have to define each one of these. And that gets pretty complicated. And that's not just me being a bad Flutter developer. That's not just an opinion. That's a fact. If we go over to the Flutter documentation, we go over to the navigation section, go to navigation routing. They start first with showing off the Navigator 1.0. If we click using the router, which is the Navigator 2.0, quote unquote, you'll see they say Flutter applications with advanced navigation and routing should use a routing package such as GoRouter. They talk a little bit about GoRouter, then they talk about GoRouter over here as well. And they're like, where's the main Navigator 2.0 that I was talking about? Well, it's hidden within this one little note over here. It says, if you prefer not to use a routing package and would like full control over navigation routing in your app, override the route information parser and router delegate. And then you can control all the aspects of it. But that's a note for advanced developers, specifically those that need some of those very niche features that Navigator 2.0 provides. And not only that, because GoRouter actually provides those features, but you want to change how all that works. But let's cover GoRouter first. So if you do need that advanced navigation, I would default to going with GoRouter, unless there's something GoRouter does not support and you really need to go into the weeds with all of this. If you do want to learn more about Navigator 2.0 and kind of the design of all of it, scroll down to the bottom here and you'll have a router design document. And here it opens up a Google Doc with 21 pages describing that Navigator. So feel free to read through this for fun if you want to. Let's go over to the GoRouter. So GoRouter, if you read the description here, is a declarative router for Flutter based on Navigator 2, supporting deep linking, data-driven routes, and more. So it uses Navigator 2, so it solves all the issues that we brought up there. And if we go to the example, it's actually way easier to use. So if you're using Navigator 2.0 in any way, whether it's through a package or original, you have to do material app.router to have routes throughout your whole application. Now, if we go to the definition of material app.router within the API documents, you have to provide a router information provider, router information parser, a router delegate, router config, and backbone dispatcher. So you can do all those, or you can provide a router config, and all these other ones have to be null. That's exactly what GoRouter does. You see we have material app.router, and we provide a router config. So it's a configuration for all your routes within your application. And let's see how it's defined. It's a lot simpler. You just have a GoRouter class with all your routes in here. You have the home page and then a details page. And then how you use that within your application is just do context.go to the details page or context.go/ to go to the home screen. You see, it's much, much simpler than implementing a whole Navigator 2.0 into your application. So when would I use Navigator 2.0? Honestly, I don't think I'd ever really need to use it. I'd even go even further. I'd say if you're not using any of these three things, let's say you're only deploying to iOS and Android, unless you have a really complicated navigation stack where you need to control things in the middle or nested things, you can still stick with Navigator 1.0. It's still fully supported, and the Flutter team, as far as I know, it doesn't have any plans to remove it because it's still good for the basic navigation where you just want to push and pop on top. But let's say you're building a Flutter web app, then I would definitely recommend going with Go Router specifically. I wouldn't recommend to implement everything by yourself with Navigator 2.0 just because the Flutter team doesn't even recommend it, and it's just way easier to use Go Router, and you get all the benefits, and you have all the web components working like the back button properly and going into nested routes, so you can go to like /URL perfectly fine. And then I would only really use this if you have some very, very specific niche case where Go Router doesn't work for you and they have to learn all this and implement it. But I would say for the majority of us, we'll probably never have to deal with this. In this lesson, we'll move on to taking inputs from the user using what Flutter calls forms. The special thing about this lesson is that we finally get to unveil the big project that we will be building throughout the rest of this course. Now, you probably already know about it from the marketing and the first videos introducing the course, but just to get some excitement going, let's get a drum roll. So the project we will be building is a Twitter clone. Over the next couple lessons, we're going to be building out this login screen. Now, this design should remind you a little bit of Twitter. Their design does change pretty often, but this is something close that we can get to. We're going to be building out two different screens in the next couple lessons. First is this login screen, and then you can't really have a login screen without letting the users sign up first. We're going to add one extra thing to both of these screens, and that is some validation. We want to make sure the users are entering valid emails in the email field and a password that's a little bit more secure and has at least 6 letters and characters in it. Now let's get to the code. So we're going to start off with an empty application with nothing really in it except the app bar title changed to the Twitter clone. The very first thing we need in order to allow users to sign up is to give them a way to input some text or some characters in. There's a couple ways to do this. The most basic way is using a widget called a text field. If we save that, you can come over here, you see, you can type stuff in, everything looks great. But we're actually not going to use a text field. Instead, we're going to use something called a text form field. And we're going to have that text form field wrapped in a widget called a form. Now, this looks exactly the same as a text field looked. So why did we do it this way? Well, the text form field has a very special property on it that we will need to use called validator. This validator property allows us to define what a valid input is for that specific field. In the next lesson, I'll go a little deeper into this validator and we'll actually define how to validate the data, but that's why we need to use a text form field instead of a text field. The second thing is this form. So the reason we need a form is because we're going to end up having 2 text form fields. We're going to have this one for the email, and then we will have another text form field for a password. What the form allows us to do, it allows us to validate both of these form fields instead of having to validate them individually. We can just get all the forms within the specific field and validate them all and see if all our entries are valid before we move on to logging the user in. So now we're able to get the data, we're able to type it in, but we don't have any way to submit it. So let's add a button before we do anything else. We're going to do an elevated button, and we're going to have a text inside saying to submit. So looking at our application, we have all the components we need in order to have a person log in. But if we submit, nothing really happens. These text form fields aren't tied to the actual button. And that's because we don't have anything retrieving that data and using it at all. If we hover over the text form field, we'll see they have a property called controller. And it is of a type called text editing controller. Now the Flutter team is very creative. They named this controller in a specific way because it controls the text that you are editing. Think of this as like a manager for whatever the data inside your text field is. The special thing that it manages is retrieving the actual text that is within the text field. Let's go ahead and define 2 controllers. We're going to have one for the email and then one for the password as well. And we can assign each controller to its specific text form field. Okay, so now our controllers are assigned to the text form fields, and the next step is to retrieve the data from them. We're not going to implement the whole sign-up authentication and all that stuff just yet, coming up in the next couple lessons, but we're going to just print out the information that the user gives us. So first we want to print out their email, and you retrieve that by calling the email controller and getting the text within the email controller. And let's do the same thing for the password. And let's spell password right because this is a official Twitter application. Okay, so there we go. If we bring up our terminal, our debug console, and we type in an email, let's say tadas@gmail.com, password, a very secure one of 123456. If we click submit now, we should be able to see it pop up here, and we're able to retrieve that text from our form fields and later on use this text in order to actually log the user in. So that's how you retrieve the text. But let's get back to the text form field. If you've used Twitter or any other big application, you'll see that the email field usually has a slightly different keyboard. It usually has an @ symbol and a period to make it easier for you to type in your email. We can do that in Flutter too. The text form field has a property called keyboard type. And we can set the text input type to be email address. So we save that and we click back into that email field. You'll see you get an @ sign and a period within our keyboard. Makes it a lot easier for the user to type it in. Now the password. This doesn't look very professional either. Anybody can snoop over your shoulder, see what type of password you're typing in, especially if you use this password for many other applications. That's not a good sign. That's not very secure. Thankfully, Flutter allows you to handle that as well, using a property called obscure text. If you set this to true, now you have little dots, and when you're typing in your password, nobody can see what you're typing, and it's a little more safe. Now, the last thing that we got to add to this form. When you're looking at this, you have no idea what these text form fields are. If we just leave it like this, people are going to get to our login screen, and they might just be confused, like, what is this for? We need to somehow let the user know that the first one is an email and this one is a password. We can do that by setting some decoration. If we go to the property of decoration and add an input decoration and then a hint text, which we can say enter an email. And we save that. We see when there's an empty field, we see the enter an email text. And as soon as we start typing, it goes away and takes in our actual email. Now we can do the same thing for the password, except here we'll say enter a password. So now we're able to type in an email. Using a keyboard that is specific for emails. We're able to type in a password with our text obscured so nobody could see what we're typing. And then when we click the submit button, we're able to see it pop up in our terminal with all the values that we inputted. Now in the next lesson, we're going to add some validation to this to make sure that the inputs that they're giving us are valid. See you there. In the previous lesson, we added our input fields, but we have a major problem. If we don't add anything into these fields and click submit, this code right here gets executed. If we add in some random numbers in here and we click submit, it gets executed. Now, that's no good because once that print statement becomes an actual sign-in attempt, we're going to have a lot of failed-in sign-ins and sign-ups. And if they are somehow able to sign up, they might sign up with something that's not an email or with a really easy to guess password, and that's just a big headache. All this means extra cost for you, the person developing applications, because you're paying in the authentication servers all the time and you're getting charged for that every single ping. It's as if you're going to get your driver's license and instead of giving your address, you put your name in that field or something else that's random. And every time you have to go back because obviously that license won't be accepted anywhere and you have to pay for a new driver's license to get created every single time. In this lesson, we're going to make it easier on the user so they can only enter information that is valid. That's exactly why we use these text form fields, if you remember from the other lesson, because they have a validator property here. Now we're going to define what is actually valid within this text form field, but before we do that, let's do the check that checks whether the fields are valid. If you remember, that's why we put everything within a form, because the form will be able to check both of these text form fields, whether the information in there is valid. Now to do that, we need a key. Now there's a whole lesson about keys coming up, but we don't need to get too deep into it here. All we need to know is this key will allow us to find this specific form so we can execute the validation for anything within this form, which for us is these two text form fields. So let me go ahead and define that key. I'm going to call it sign-in key, and I'm going to assign it to this form. So again, this key identifies this specific form, which allows us to do actions on that form, like validating the text form fields within it. So we take that sign-in key, we take the current state of that form, and we can validate it. Now, if we take a look at this validate function, we see that it returns a Boolean. The description tells us that it validates every form field that is a descendant of the form and returns true if there are no errors. So we can do a conditional if statement around it. If the fields are valid, which means it returned true, we can print these fields. Now let's go back to the application. We try the empty string again. You'll see it still gets printed. Now why is that? That's because we haven't defined what valid actually means for each of these text form fields. So let's first start with defining what a valid password is here. Well, we know one thing for sure is we don't want the password to be empty. So we can take the validator field. It gives us a value which is currently what's inside the text form field. And we can do a check for if the value is null or if the value is empty. That's not a proper null check. You need the double equal sign. The reason we need to check both null and is empty is because if you first start up the application, nobody clicks in it, and you just submit, it will be null. But let's say you put something in there and then you remove it, it's going to be an empty string that looks like two quotes with nothing in it, and that's what the is empty checks for. Let's go back to the validator. You see it returns a string. So the return value of this validator, if everything is good, will return null, basically saying there's no problems here. But if we have a problem, like over here where the user didn't enter anything, we want to return a text telling the user what the problem actually is. So here we're going to tell the user to please enter a password. Now, if we click submit, we're validating the forms here. You see, it tells us to please enter a password. Now, within our password, our only criteria is that it's not empty. So if we put in one letter or one number, in this case 1, you see it gets executed. I think we could do a little bit better than that on security. Other websites, including Twitter, sometimes make you add letters, numbers, special characters, and even capital letters. But another way to make it a little bit more secure is just to check the length of it, make it longer. So we're going to add a validation that checks whether the password is at least 6 characters long. So we're going to check for another condition. We're going to take the value of our string. We're going to see the length of it. And if it's less than 6 characters long, we're going to return another issue saying password must be at least 6 characters. Okay, now that one number we had added in, if we click submit, password must be at least 6 characters. And if we add in the 6 characters, then it will finally get executed. Okay, so our validation for the password is defined. Now we're going to need to do the same thing for our email. So now if we have an empty email that says, please enter a password, that's not correct. We need to update that to please enter an email. And if we submit, there's an email. And the second case, we don't really want to define a length for the email because some emails are short, some emails are long. That's not a good way to validate it. What is a good way is to check whether the email follows email standards. So whether it has an @ sign, whether it has a period in there, whether it has 3 strings. So for the length of the email, that's not really something we want to check because some emails are short, some emails are long, but we do want to check whether they follow the standard email conditions. So for example, we want to make sure it has this @ sign. We want to make sure it has a text before it. We want to make sure it has a text after it. We want to make sure it has a period and that it has a dot something afterwards. Now we can do this using something called a regular expression. And we're going to cover regular expressions in the next lesson. So for this lesson, we set up a check for whether the current state of the form is valid. If it is, we're able to print an outcome. We define what valid means for the password. We define part of it for the email. In the next lesson, we're going to take it a little bit further with regular expressions. See you there. So a regular expression is a sequence of symbols and characters expressing a string or pattern to be searched for within a longer piece of text. Basically what that means is it finds very specific characters that you define within any piece of text that you want. Now regular expressions are a pretty niche topic that you'll probably not use too much in your professional career. And even if you do, there are resources out there to help you find what you need. For example, there's regexlib.com where you can enter a keyword, let's say email for this case, and the search results will pop out some regular expressions for you that cover emails. Now this one is an overly simple one, and it can get different levels of complexity for your email validation. Now the regular expression we're going to use today is this one. And to go through and learn about what this actually does, I'm going to highlight, paste it into another tool called regexr.com. So this tool has a lot of cheat sheets and stuff you can learn about with regular expressions. And you can also paste in the regular expression here, and it'll show it to you within your text. So let's say we put in tadas@gmail.com. You'll see it gets highlighted, and we have one match for this regular expression. And the real nice thing with this tool is we can actually go through and highlight each part and see what it actually means. So what does this regular expression mean? Well, if we highlight over this, it means first, we need to start with something that matches anything within this character set. So the first part needs to contain one of these characters. And this plus tells you it needs to contain one or more of these characters. After that, it needs to be followed by an @ sign, followed by one or more of these characters, because there's a plus, so something from here can only be letters and numbers, followed by a period, it has to be a period, followed by one or more of these characters. So at the end, we could have a UK, but we can't have a UK 9 or a 9 UK. That doesn't work. For Gmail, we can't have a $sign in there, for example, because that becomes an invalid email. So that's how regular expressions work. So if we actually go back to our code, we can actually check that whatever we enter into the email field fits our regular expression. So first we check whether it's empty, then we check if it has a match with the email that we inputted in. Now this expression here checks whether it matches a valid email. So we actually want to do the opposite. So if it doesn't match a valid email, we need to return, please enter a valid email. There we go. Let's test it out. We do Tadas. If we just click submit, please enter a valid email at Gmail, let's do a $sign in there to make sure that works. Gmail.com. Submit, please enter a valid email. Let's actually do the password so you don't see that. But then if we replace that $sign with an L, should be valid, and it should be good. There we go. So that's our form. We're able to enter our email, our password, and we're able to validate that that information we entered is correct by clicking this submit button. The next step is to make this look a little prettier. Now, if I was logging into Twitter and I saw this login screen, I'd be scratching my head quite a bit. So we definitely need to take this lesson and make it a little bit prettier. Now, to start off, I think the Twitter team could do a little bit better than the default app bar that we have here. So we're going to remove that app bar. Instead, we're going to add a piece of text here that tells people to log in to Twitter. Now, a couple of things wrong here. First, that text is not even viewable. It's behind that little pill bar. And actually, this whole thing doesn't really look good all the way up here. We should center it. We do that by centering the main axis on the column. So set main axis alignment to center. Now, the text here is a little small, so let's make it bigger and bolder by adding some styling to our text widget. We're going to make the font size 18 and make the font weight bold. Okay, that looks a little better. Now next, these form fields not looking too good. What we're going to do is put a nice background of gray so that you know it's a form field. Remove this underline and make it rounded so it looks more like Twitter. To do that, we're going to add a widget called the container widget. Remember, the container is one of the most flexible widgets, so we can style it exactly how we want. We're going to add some decoration. This is where we can set our background color, and we're going to do gray with a shade of 200. If we save that, that's what that looks like. And we're also going to give it a little radius. It's very tighter on the edges here, and very close to this little text up here, so we need to give it a little space from everything. We're first add margin, which, if you remember, is anything outside of the container, how much space you have from the edge to any other things around the screen. So we're going to do from LTRB, which is left, top, right, bottom. From the left side, we're going to want 15 pixels. At the top, we're going to want a little bit more separation between this and the text up here. The right side, we got to make it even on both sides. And the bottom, we're going to keep it 0 for now because we're going to actually handle that on the password decoration part. So you save that. There's a little bit of spacing. Now I see the enter email inside here is very tight with the edge of the container. So in order to give some space here, we need to add some padding. To do that, there's actually a field in the text form field decoration section. So here we do content padding. Now we're going to do a symmetric. A symmetric is where you keep the left and right equal and the top and bottom equal. So vertically, we're going to have 15 pixels, and then horizontally, we're going to have 20 pixels. Okay, that gives it a little space. Now this line is still underneath here. And we can get rid of it by doing input border dot none. Now that's looking good, but one little detail is I think I want a little bit more space between the enter email and the top of the container. So we're going to add a symmetric padding that is vertical. And we're only going to add 10 more. Now I like how that looks a lot better. And we're actually just going to copy paste the same exact thing to the other field. First, we're going to wrap it with a widget, the same container widget. And we're going to paste those fields in there. And we're also going to take the decoration within the text form field into that one as well. Now, if we take a look at that, it's a little weird. It seems like there's too much space here and not enough space here. So I'm going to change the container padding to just be the same all over. So just 15. Save that. I think that looks a lot better. All right, the next thing we got to deal with is this submit button. It doesn't look too good. Doesn't really fit the whole style we got going here. Let's Twitterify it a little bit. So first, I'm going to make this button into a text button. And then we're going to wrap it in a container widget again to add some styling to it. I'm going to give it a width of 250. Add some decoration. We're going to make it the same blue like the Twitter blue and give it some nice radius so it's circular. And have it be the same circular radius that we had for all these forms so everything looks aligned. Okay, now that's a bit of a mess because our text is the same color as our background. So let's change that. We just change the text style. We're going to change it to white and actually make it a little bit bigger too. All right, I think this is looking a lot better now. Now there's one more thing missing from our login screen. You can't really log into Twitter unless you have an account there. And you can't really have an account unless you have signed up to Twitter. So we're going to take a very similar thing to this and we're going to create a sign-up screen. So we're going to copy most of what we've done here and we're going to create a sign-up screen. Before that, we need to add a button to bring you to that sign-up screen. So the text is going to say, don't have an account, sign up here. And we're going to wrap this with a text button. We need to add an onPressed method, so whenever we press it, we can actually send it to another screen. I've done this before in the previous lessons. To navigate to it, we're going to do navigator.of. We're not going to create a named route for it. We're just going to push the route directly. So material, page route. I want to call that widget sign up. Now we'll see an error for now because we haven't created this sign up widget yet. But what we're going to do is just copy this whole home page. Do Control-C, add a new file, signup.dart, paste it in. And you'll see there's a whole bunch of errors throughout the whole thing because we haven't loaded in the material library, so it doesn't have access to those widgets. And now we can take the My Home page. Like I said, if you click Command-D, it starts selecting every part of the My Home page. And now we can name it to something like Sign Up, which is what we named the widget on the main screen. Now we do have to change a couple pieces of text here. So this one says log into Twitter. We need to change it to sign up to Twitter. Enter your email is all good. Password, everything is okay. Submit. We can actually change that to sign up. And then we should change the text at the bottom to say already have an account. Login. And this should just pop us back to where we were previously. So instead of push, we do pop. So then we have this defined. Now we need to import it. That brings our import statement at the top. We should be able to save it. And now when we click, it takes us to the sign up screen. So one tiny little detail is I changed this to sign up. Let's change this submit to say login. Just to make sure people have the right instructions. Okay, so there we go. We have the login screen and then we have the sign up screen. Both of them have validation to make sure we're putting in the right fields, and they're looking at least a little bit better than they were previously. But there's one big thing missing from this login screen, and that's branding. We need to add in a logo at the top so everyone knows that this is Twitter and we can't be mistaken. That'll be in the next lesson. If you are building a company, you need to have a logo, and it needs to be everywhere, especially on the login screen. So the Twitter logo is a very important asset to have here. Now the way we're going to be adding it in is we're going to create an assets folder. And name it assets. And we're going to bring it out into the main directory of our whole Flutter project. So within this assets folder, I'm going to drag this Twitter blue.png file. This file is linked below the lesson if you want to use the same one. So it looks just like this, just like a Twitter logo. Now it is within our Flutter project, but it is not within our actual code base yet. It's just a random folder. To add it into the code base, we need to go to the pubspec YAML. We're going to add it under this Flutter section. We're going to do assets, and what we're going to do is we're going to add the whole folder. You can name the files individually, but since we're going to be using everything within this folder, even though right now it's only just a Twitter logo, we're just going to do assets / to include the whole folder within our code base. So that's saved, and we're actually ready to use it right away. In order to use it, there is a widget called the image widget. We're going to pass in an asset image, and there are different types. For example, a common one I use is a network image. And this asset image is in the assets folder, and it's called Twitter blue.png. So now we should be able to run it and see a Twitter logo here. And there we go. There's our giant Twitter logo. Let's make it a little bit less giant by setting the width to be 100. And let's also put a little bit of space between this login to Twitter and the logo. And we're going to do that by adding a sized box. And we'll give it a height of 20 pixels. All right. Now if we save that, there we go. Our logo is in. It looks pretty much like a Twitter login. And remember, we also have a sign-in screen. So if we go to this, let's add it in here. Save it. So there we go. Both our login and sign-up screen have the Twitter logo, and it's looking like a real app. But there's a different way we could have done this. In the next lesson, we're going to cover packages. So there is another way we could bring in that Twitter logo into our application, and that's using something called packages. Now, pub.dev, which is the URL, is the official package repository for Dart and Flutter applications. So what is a package? Basically, it's a piece of code developed by someone in the community, and some of them are even developed by the Flutter team themselves, that makes it even easier to build your Flutter applications. So you don't have to implement everything from scratch. Now, this can include a wide variety of things. Some examples here are authentication, being able to easily handle location for iOS and Android devices. There's things like APIs, animations, little UI elements, even like buttons, and there's just so many packages. And one of those packages is called Font Awesome Flutter. So if you search for it, this is the first result. If we look at the description, the Font Awesome icon pack provides 1,600 additional icons to use in your apps. Basically, this thing just gives you a ton of free icons, and one of them is the Twitter logo. Now, to bring it into our project, there's two ways to do it. One, you can just click these right here and copy the package name and the version to your clipboard. And we can go to our pubspec.yaml file, go to dependencies, paste that in, and click save. And right here, it's running Flutter pub-get, which brings the package into your project. So that's one way to do it. But let's remove it, save it. There's another way to do it within VSCode. We can even close this. If we click Command or Control and then Shift P, It'll open up this window, and there's a command called add dependency. Now we can search for font awesome Flutter. And we save it. It's adding that package, running the same Flutter pub-get that we saw. And if we go back to our pub-spec YAML file, you'll see the same exact thing we copy-pasted is now in here. So whichever way you choose to add it in, it is now within your Flutter code base. So we're ready to use it, and I want to achieve the same exact thing that we had in the previous lesson. So to do this, we're going to be using the package. The package gives us a FA icon widget. The icon here is something that's defined by font awesome icons and then Twitter. So now we should be able to save it. See a little Twitter logo there. Now we can give it some color and change to the same blue color that we had with the previous logo. And it looks like that. Now make it a little bit bigger and then add back that spacing that we had between that and the text. And there we go. We achieved the same exact thing as we did in the previous lesson, but now this time we used a package. We can do the same thing on the sign-up screen. And you see we got the red underline is because this hasn't been imported at the top. On the main screen, it got automatically imported for us, so this package that we're using is brought into our file and is able to use it. We can go to this FA icon, click Command period, and import that library. And now we should see it on the sign-up screen as well. Now, as we're building this app, I personally would just use an asset because we're only going to have one logo and one asset used throughout our application. But let's say you needed a lot of logos, then it makes sense to just import this one package and be able to use it wherever you need within the app. So we covered how to add packages and assets into your pubspec.yaml file. And that is the main way you will be using that pubspec file. So while we were writing up our Twitter form, we added this sign-in key, which was a global key. At that moment, I told you not to worry about it because we're going to cover it in a later lesson. Well, this is that lesson. There are two types of keys, local keys and global keys. Global keys are generally used to find a specific widget. That's actually what we use for our form. Since we wanted to be able to get access from a different part of the application, we added a global key for it. Now, local keys are there to solve a very specific problem. It's to help to make sure that widgets of the same type do not get confused. Now, in order to explain that, we're going to go back to the widget tree. If you remember, the widget tree is just a blueprint for what your app looks like. And then there's also the underlying element tree that is in charge of location and where that widget is. It also tells the widget which state belongs to that specific widget. But the bad part is it doesn't have that much more information other than that. So you use keys to kind of give it a little bit more information so that it knows what's going on, so make sure that the right state is associated to the right widget. Let me show you through a couple examples. Okay, so here's a very simplified widget tree. We have a row, a text, and a column with two container widgets. Note that these containers are both of the same type. They're both container widgets. However, this situation only happens when you have both a stateful widget and you are manipulating widgets of the same type. So we have this widget tree. Whenever something changes here, this section gets rebuilt. Now, how does it get rebuilt? It checks whether this widget is the same type of widget and if it needs to get rebuilt. This is done because let's say you have a big widget tree and there's a bunch of other widgets down here and a lot more. You don't want to have to rebuild literally everything below it. So then let's say we have the case. Let's remove the state for a second of these two container widgets swapping places. So let's pretend that one moves over here. This one moves in this spot. And this one takes its spot. Your widget tree will start going down the list. We're saying all of this gets rebuilt. So it'll go down, it'll check here. It checks, is this equal to a container widget? Pass the check, so then it does not need to get rebuilt. And it gets assigned the state of blue. The same thing happens here. It checks down this widget tree. It checks if it's equal to a container widget. It is. So it gets assigned the state of red. And that's of course not true. We literally just swapped these. They're supposed to be the other color. And that's where keys come in handy. So keys add an extra little identification for each widget. So for this one, let's say we do C1, and then this one is C2. Now we know C1 is supposed to be red, and C2 is supposed to be blue. This time, we're swapping places. The column checks, is this equal to C2 like it was before? And it's not. So it means this widget needs to be rebuilt. It doesn't just rebuild it from scratch, it actually looks if it's anywhere else in the application. It actually does find it, but it makes sure to assign the right color to that one. Then we do the same exact thing with C2. You check, is this equal to C1? It's not. Looks through all the widgets, finds that blue is supposed to be associated with it. Now this way you make sure the same color stays with the same container just like you want it. You could think of it like an identification number. Let's say there's two people named John Green, and maybe they're even twins, and then they decide to change their hair color. You'll still be able to tell them apart by taking a look at their state ID and seeing that their identification number is associated to the correct John Green that you were thinking of. Now we're actually going to go and showcase this specific situation within our code. Okay, so I built out an app called the Color Swapper. We're not going to go through all the code because it doesn't really matter, but the important thing is that we have these two squares that when you click this button, they're supposed to swap the colors. Do that using the insert method, which takes the tile at position 0, removes it, and inserts it in position 1. So the one that was in position 1 moves over to 0, and then this one moves over to the other one. Now at this point, we don't have any keys assigned to them. So there's no keys, no nothing, and when we click this plus, nothing happens. But let's say we add a unique key to both of them. We save it and rebuild the application. We'll click on it and they swap. If we actually click Control-Shift-P and open the widget inspector, we can notice the actual swap happening. So you see the color tiles, they have this key number, so C0, C2E. If we click the swap and refresh, you'll see the second one will be the C0, C2E. There we go. They swapped. And if we remove it and rebuild the application, we no longer have a key associated to it, but you can still see which render object it's using. So render object is the actual thing getting displayed. Remember, there is the widget tree, element tree, and the lowest level is the render tree. All you need to know here is that the render object is the actual thing getting displayed, and we can see the identification for it here. So we're looking at the first color tile. We'll see the render object associated with it is 78D5C. If we click swap and we refresh, you'll see nothing changed. We have the same exact render object. So this is the situation where you need to use keys. You might not need to use them too much, but if you ever run into this situation, you definitely need to know how keys work. You'll probably use keys a little bit more commonly, and we even had to use it within our signup form. And that is the basics of keys. This section is called Tea Time with Tadas, and here we're going to discuss some things about Flutter Web. So I mentioned before that Flutter isn't the best solution for all websites right now, and specifically made for web apps, not really websites. So normally the web is laid out using HTML, CSS, and JavaScript, and the way most websites get found is through search engines like Google, and the way you rank up higher in the search engine is you configure HTML to have the proper keywords, and that's called search engine optimization, and that's what Google has been using for all this time, and it's the popular way for your websites to get found. Now that's one of the biggest use cases for having a website right now. But web apps specifically are growing in popularity, and for those, SEO doesn't matter. Now Flutter, like I said, is built for web apps. Now, let's give you some examples of web apps. So this is called Rive. This is an online editor that lets you create and define animations that you can export into your applications. Now you see, it's pretty complex. All your elements here, you have the animations here, you have the different things you could add to it, your animations, like changing the color and everything like that. It's a pretty complex web app that is running within your browser. The fun thing about this one is it's actually built with Flutter. Another really popular solution is Figma. So Figma is like a design tool, then this is how the website looks like. You also have layers here and different ways you could interact with it. And use cases like this are perfect web apps. So Flutter could definitely be used for something like this. Might not be easy to build because this is a complicated app and there's a whole company building this. But in theory, Flutter would be a good solution for this as well. Now here's some other quick examples. Netflix is a good example of a web app. You log into it first, and then you pick whatever show you want to watch, and you watch it on there. And you notice all these examples, SEO doesn't really matter because there's no ranking for your animation, and there's no ranking for the design that you're putting in on Google. You're not going to be able to search for this directly. You need to log in and then be able to use it. And same thing with Google Drive. You're uploading files. You don't want those to be searched on Google. Office 365, you have your Word documents or Excel sheets. You don't want those to be searched on Google. And Notion is a very similar. All these are built on the web, and they're meant to be interacted with. That's what web apps are. Websites, you go, you get information, you take it in, you read about it, you learn about it. While a web app, you go in, you're actually interacting with all the other objects in there. Now, there are a couple of technologies that I think could make SEO less relevant or web apps more relevant. And I wanted to discuss them here. Now, this is just a prediction. Who knows? Maybe web apps and websites stay in this current state forever. I don't really know, but these are interesting developments in the web world. So first is WebAssembly. Normally, I said websites are built with HTML, CSS, and JavaScript, and your browser will interpret that, and then Google uses the HTML specifically to kind of filter through and scrape your website to see what it wants to show as the first result. Now, WebAssembly is an assembly language, so it's a layer lower than regular code like JavaScript, but just above machine code, which is just ones and zeros. So it's very efficient. And you can compile it to WebAssembly from any language pretty much. Specifically, people will probably be using C, Rust, and C++ because those are very fast languages. And the benefit of it is you can make websites that are very fast and responsive. Now, there are some cases where JavaScript might be a little bit faster, maybe for documents specifically, but if you're making a web app, I think this could be a really good way to build it. Now, WebAssembly is the fancy new thing coming to websites, and people believe that it could maybe become a big part of the future of the internet. It's hard to really predict these things, but Flutter has already been working on it. Just announced at Flutter Forward, they released early support for Flutter being able to compile to WebAssembly. So if this technology becomes a big part of the internet, Flutter is well placed to take advantage of that. Now, the last technology that's pretty interesting that could maybe make SEO less relevant is ChatGPT. So ChatGPT, if you're not aware, is an AI chatbot that you can interact with, and you could ask it any questions out there and it'll answer it surprisingly well. It's kind of scary good sometimes. And Microsoft has a huge stake in the company that owns ChatGPT OpenAI. And recently they put in an even bigger stake. Now, currently Bing search is definitely not used that much and way, way less than Google. But I could definitely see it becoming a lot more popular if they do implement this properly. Because with Google, you type in your search and there's a whole bunch of sponsored articles at the beginning. Sometimes you have to make sure you type it in really properly for it to give you the right answer. While with ChatGPT, it just gives you a good, clear, well-rounded answer right away. Now, the thing about AI models is that there's no HTML or CSS to parse and to figure out what has to rank higher. So if Bing does implement this properly, Google will need to change how it does its search engine optimization. And with that, maybe web apps become even more popular. Maybe the current structure of SEO sites will have to completely change. And who knows, maybe in the future, you will be able to build Flutter sites that can rank high on search engines. Now, I don't really even know, maybe this wouldn't even really be a search engine, but just interesting things to think about that I'm keeping an eye on for the future. Now, this doesn't mean that Flutter Web right now, you should be building websites because it might be the future. I still think JavaScript will be around for a long, long time, but web apps are right now and will continue to be an important part of the internet. And maybe if these trends continue, they will become an even bigger part of the internet. So now we're going to take a little break from our Twitter clone to cover some core concepts that we're going to need for the rest of the application. Want to make sure we have our toolset built out so we can finish the Twitter app in a very professional and effective way. Now, two big topics we need to know in order to continue with this Twitter app is user interface and state management. In this specific lesson, we're going to cover the different types of layouts that you can have in your Flutter applications. We already covered layouts throughout the first couple places, but I wanted to have a specific course on layouts so that if you need to reference this again, you know exactly where to go. So the first one that we've used before is the row and column layout structure. This layout is actually very common throughout many frameworks, and it sets up your application kind of in like an Excel sheet. You can add a specific widget in a place relative to other widgets throughout the screen. But there are also Flutter-defined layouts. One of them is the list view. It displays things in a list. Now, the first question that comes to mind is, why would you use a list view instead of a column? Well, adding things to a list view has an extra feature of it doesn't render items that are not visible. So on this list, let's say there's some things off of the screen. Those don't get rendered until they come into the screen. There's also grid view, which is very similar to a list view except grids. And then a stack, which allows you to put widgets on top of each other. There are many more layout widgets, and for the complete list, please visit the widget index. Now you can have some more advanced UIs using something called slivers. So slivers allow you to have a custom scroll page where you can mix in a whole bunch of elements within your application and have them scroll really nicely. So this is just a couple of examples. See, they're a little bit more complicated. The app bar expands there. This one, the sections come together, and you could build more complicated scrollable views. So I actually wanted to show a quick demo of slivers. We're not going to write out the whole code because we're just trying to get the gist of how slivers work. But in order to create a nice sliver view, you need to wrap it in something called a custom scroll view. And then within this custom scroll view, you're going to have a bunch of widgets. All these widgets need to be slivers or else they won't render properly. So here we have a sliver app bar, we have a sliver grid, and then we have a sliver fixed extent list. So this allows you to have a little bit more of a complicated scrollable view, and since it's an application on a phone, scrollable views are very common. So you might need to use something like this. And you just add in whatever sliver widgets you need inside. And to get a full list of all the sliver widgets that could fit in here, please go to api.flutter.dev and look in the left side. There's a whole bunch of little sliver widgets that you can add to your custom scroll view. So that's an overview of the different layouts you can have within a Flutter app. Next, we're going to get into the different design patterns that you can have within Flutter. The two most popular platforms that are built with Flutter are Android and iOS. Now you can make your designs completely custom, but each of them have their own design language. So Material is the design language for Android. And if you remember, we wrap our application in a Material app. Now you can still customize your Flutter app as you wish, but when you wrap it in this Material app, you get some of the Material design patterns by default. So you can actually visit the website material.io and go through, for example, the components. So this component is a card, and you can have an elevated card, you can have a filled card, outline. They can give you specs and even some guidelines to follow in your applications. And all of these are followed whenever you are using the Material app. Now you can also do the same thing specifically designed for iOS. So iOS style is called Cupertino. I can actually go to the Apple design website, go to the guidelines, and see a very similar layout like we saw for Material. You can click into these and it shows you, for example, the chart's anatomy, some marks, axes, some best practices, what kind of colors, and whatever you need for your iOS style application. And so just like we have a Material app here, we can actually change this to a Cupertino app. In this case, now we need to import the Cupertino library because before we were using the Material. So we say that we actually have to reload the whole thing. You'll see we still have a bunch of issues. If we go back to the main document and actually remove this Material import, a lot of our widgets that we have don't actually work. That's because when you're using a Cupertino app, you actually need to update these to Cupertino specific widgets. So the scaffold needs to be a Cupertino page scaffold. And the page scaffold doesn't have an app bar, instead has a navigation bar. We change that to navigation bar. This turns into Cupertino navigation bar, and it doesn't have a title. Instead, it has a middle property. Now, instead of body, we actually have a child widget here. And lastly, instead of just a theme, we have a Cupertino theme, which doesn't have a headline property, but it has a nav large title text style. So now if we save it and we run it, we need to reload it. There we go. This looks now more like an iOS application. We actually don't have a button to add anything. So let's add a text button up here. Let's add a Cupertino button at the top. The child will be a text that says, actually no, an icon. And this time it has to be a Cupertino icon. And we'll have it be an add icon. And update this to increment our counter whenever we press it. Okay, so there we go. Now this is styled in a Cupertino style. You can see it looks a little bit more iOS, and we can click the button. The button looks more iOS style, and we're able to increment our counter the same way we did before, just with a completely different design pattern. In order to see all the widgets, we'll add a link below, but there's a Cupertino iOS style widgets catalog here. You can see all the widgets that are supported by the Cupertino app. So that's material and Cupertino design. So next, move on to understanding constraints. When you're dealing with layouts, there's a mantra that the Flutter team wants to remember. It's constraints go down, sizes go up, parent sets the position. Now let's repeat it together. Constraints go down, sizes go up, parent sets the position. Does this look like a joke to you? We're going to keep doing this until everybody's repeating with me. Constraints go down, sizes go up, parent sets the position. Okay, good. Now we can move forward. So what does this actually mean? Let me walk you through how Flutter builds and lays out the widgets. So first part, constraints go down. Specifically, they go down the widget tree. So you have a parent widget, and then you have a child widget. The parent widget tells the child that it only has 10 pixels maximum that it could be wide. So that is the child's constraints, 10 pixels. And yeah, I highlighted that this is going down the widget tree. So the parent is above it in the widget tree, and it gives the constraints downwards to the child. Again, it tells the child, you can only be maximum 10 pixels. And sizes go up. So the child tells the parent, it only wants to be 5 pixels wide. The child is lower in the widget tree, so it's telling the parent how big it wants to be. But then the parent is the one that sets the position. So he says, okay, you can be 5 pixels, but you have to be in the middle. So the parent sets the constraints. So constraints go down because the parent is telling the child what its constraints are. Sizes go up because the child tells the parent what size it wants to be. And the parent sets the position, so it tells the child where it's going to be. So in the Flutter documentation, there's a section called Understanding Constraints. And you see the same thing. Constraints go down, sizes go up, parent sets position. They have a whole bunch of examples down here, and I'm going to link this site below the video so you can go and check it out yourself. But I wanted to go through a handful of the examples. So the first example is just a container, and they colored it red so you can see what's happening, as the screen of this container is the whole parent. And here they tell you the screen is the parent of the container. So that forces the container to be the exact same size as the screen. So the container takes up the whole screen. But if you tell the container the exact size it wants to be, it tells the parent it's not going to take up the whole screen. Instead, it's going to be 100 by 100. So in the second example, you would think that since we're defining the size, it wouldn't take up the whole screen because we said sizes go up. But there is no widget tree above here since the screen is the parent, so it has to still be stretched across the whole screen. Now in the third example, there is a parent widget, and that's a center widget. So this time, the sizes go up actually works, and you can size the container to be the widget size you want. So in this case, it didn't work because something has to fill the screen. The pixels have to have something on there, right? So in this case, the center part is the one that fills the rest of the screen, and the container can now be the size that it defines. Example number 4 is using the align widget. So this is the parent defining where it is located. Example number 5. So on the container, they did a width of infinity and a height of infinity. It doesn't actually go to infinity because the constraints go down. So the constraints of this center widget get set to the width and height of the container. The container wants to be infinite, but it just can't go bigger than the screen because its constraints are set. So there's a lot more examples, but I wanted to skip to example 24 because this is something that happens very commonly. So when you use the row widget, it doesn't have constraints this way. So you'll see this error warning pop up on your Flutter application that says that you overflowed over the screen. That's because there's nothing defining the constraints for the row. The row is infinite length. So what we do in this example is we wrap it in an expanded widget. The expanded basically says take up all the space that you can horizontally, but don't go over the screen limits. So in this case, we have a container here, the green one. It's the same size that it is. So if this was more text, it'll be wider. And then this expanded widget says this is all the width you have to work with. So fit everything within that width. And then if you put the container in expanded widget, these just set it to the equal width for each of them. So basically, since there's 2, it expands equally by taking up only half of the screen. So in this case, since there's only 2 expanded, it expands equally to take up half the screen for each piece. So that's a little bit about constraints. And if you run into some of these issues, hopefully you'll be able to understand that constraints go down, sizes go up, and parent sets position. So now I want to explain these constraints to you within some code. And then we're going to run into a problem with constraints and figure out how to solve it. So once again, constraints go down, sizes go up, parent sets position. So here we have 2 containers. This container has a width and height of 200. And we said constraints go down. So this is above this container in the widget tree. And this container is 100 by 100, so smaller. It's the blue one, and then this is the red one. So this main container is above this container in the widget tree. So this one makes the constraints go down. So constraints here are 200 by 200. Let's say we want to change this blue container to be 300 pixels wide. You can save it. You'll see it doesn't go past 200. And that's because this container sets the constraints. Now, sizes go up. So if we set this to being smaller than the constraints, this container specifically sets what size it wants to be. We can set it to anything like 40 and even 190. So we can set whatever size we want for this container to be. Now, last part is parent sets the position. So you see, we set the alignment here. We aligned it to be in the center, but we could align it to, let's say, bottom left. So this parent, which is the widget above the lower widget, is the one that tells it where that widget is supposed to be. So now let me show you an example that very commonly breaks your application. The row widget. So in the row widget, let's say we have a text field in here that is just super, super long. We'll save it, and right away you see an overflow problem right here. Our text in the row widget has overflowed by 118 pixels. So why does that happen? Remember, row goes all the way horizontally. That means there's no constraints for it in the horizontal position. So when the text or the widget below it in the widget tree doesn't have a horizontal constraint, it can go past the edge of the screen, and we run into this specific issue. Now, the way I would solve this is by wrapping this text in a widget called expanded. Now, if we save it, we'll see everything looks fine. So what does expanded do? Expanded tells the widget below it that to expand to the furthest distance that it can, and it basically gives it its own constraints. So an expanded gives the constraints to the widget below it on the maximum width that it can be. So expanded is often used when you have multiple things in a row and you need to make sure they're all displayed. So if we have 2 of these long text widgets, you'll see expanded will take up half the screen here and half the screen here, because each one will expand to the furthest that it can until it touches each other. And there we go. Now it's kind of hard to see, so let's turn one of these red. There we go. As an expanded widget, you can also give it a little leeway. So it has a property called flex, and at first flex equals 1 here for both of these expanded widgets. That means that with all the expanded widgets, it's going to have a ratio of 1 to 1. So let's say we want to make this one a little bit bigger. We can set the flex here to 3. Now it's going to have a 3 to 1 ratio based on this expanded widget. So you should see the part that's not red should go all the way out to here. And there we go. And that's how you can deal with overflow problems that happen when you don't take your constraints in mind. So up until this point, we've been changing how our app looks widget by widget. But you should have some sort of design consistency throughout your whole application. For this, we use themes. Now, our default app, we've seen this theme.ofContext text theme headline for in every single counter application we built. When we create our material app, we get a default theme set up for us. But we can change many things about this. Maybe, for example, dark theme. We can even change this app bar to look a little bit different. Now, to do this, we go to the material app. And here we need to define a theme. The type is theme data. And here we can define all sorts of themes throughout our application. So let's start first by making it dark theme because, we're developers. Everything should be dark theme by default. Change the brightness, dark. Now we need to remove this constant because theme data makes it no longer constant. And there we go. We click a save and you see our whole application changes the look completely just with this little line of code here. And every page that we go to, it will be dark theme because we defined it globally. Now this app bar is a little different now because it's dark theme, but I think we can get a little bit more creative with that. So we can change the app bar theme for every app bar throughout our app. Define the app bar theme. And maybe first let's do center title and set that to true. Now this doesn't change anything here because by default the iOS titles are always in the middle. But if you were using an Android, you see this was on the left. This center title property is what I like to set up. I like things centered. But we could also change the height. So we could change it to 100. Make it a little bit bigger. We have this little black shadow over here. Maybe we want to change the color of that shadow to something gross like yellow. And there we go. Now we get a little yellow highlight. Look, you still need to have some sort of design sense because you can just make the whole app look ugly if you want to, which we're going to do here just for fun. You can actually change the shape of our app bar too. Instead of being these sharp corners, we can make it a little rounded. We can give it a rounded rectangle with a border radius of 50, and now you see it has a little bit of curve to it, so it's something a little bit more fun. Now this button down here, although it looks nice, it doesn't match our gross yellow little theme we got going on here. We can definitely change the theme of our floating action button. Change the background color to the same gross little yellow color. There we go. Now at least we're consistent throughout our app. We can also change our default font. So maybe we want something like Georgia font. See, this updates and the font's a little bit different now. And don't forget, we have this theme for headline 4. We can change that specific thing as well. So you change the global text theme for the whole app. And maybe you want to change the headline 4 to have a text style with size 36. And maybe even make it italic. Now you can't really tell because there's only one number, but if you get into the tens, you see this is italicized. So there we go. Now our app looks completely different, and this theme will be used throughout every page that we create. Now you have to be careful, of course, because you still have to know design a little bit, or you could just make the whole app ugly instead of just one screen. but there are other design courses on Zero to Mastery that you can take a look at and learn how to be a better designer so you don't make something like this. Flutter has many screens, and responsive design allows it to adapt to all the different screen sizes. Now, Android phones, of course, have many different sizes and layouts and everything, but even when it comes to iOS devices, there's a lot of different sizes and layouts that you can have. For example, there's a 14 Pro Max, but they also have a 14 Pro, which is smaller, and then a 14, which is even more different. And there's also an iPad, then there's macOS applications, which can stretch in all sorts of directions. You can also develop for the web, so that can have different sizes. Basically, responsive design is very important when you're developing with Flutter. Thankfully, Flutter has built-in tools to help us with this. Now, this is going to be the last section about UI, and if you want a deeper dive on UI and responsive design in general, there's a course in Zero to Mastery linked below for that. There are two approaches to ensure that your code is responsive, and we're going to be covering both of those. First, let me bring this window over here because we're going to be using the macOS so we can stretch and make it look different sizes to make sure we're actually being responsive. I did a little setup before this video because this code that I wrote out isn't really important to the lesson, and it's just a row and some columns. So this one is a row with 2 columns, and I called this big display. And I also created a small display, which is a column with 2 rows instead. And we can show you what that looks like. Small display, if we save it, you'll see it's literally the opposite. What we're going to be doing here is when it's narrow, it makes sense to have rows so you can see things properly like this. But when your screen gets bigger, when this screen gets bigger and wider, it makes sense to have columns. And a lot of applications and websites are set up to respond to things like this. So the main thing you need to know in order to build a responsive app is how big your screen is, the width and the height specifically. And you can get those dimensions directly from Flutter. So to get the width, you do media query of context, which is something we've seen a lot. Just take the media query of this current context. A media query is basically information about your application, like the screen size. You can do the size and then the width of this specific screen. Now we can do the same thing and retrieve the height. We're not actually going to be using the height, but I just want to show you that it can do the same thing here. So we have the width and the height of our screen. Let's actually print it out so you could see it. Yeah, let's just print the width for now. We can bring this up. You'll see right now the width is 1037. If we drag it, see how the numbers changed to 933 and so on. So that's how you get the width of the screen size. And if we go down here, we can just display the different screen depending on the width. So if our width is greater than, let's say, 500 pixels, we want to display the big display. If it's smaller than 500 pixels, we want to display the small display. Now if we save it, this must be more than 500. When we get to 500, it switches. And just like that, you have a responsive design for your Flutter application. You might have noticed this button that doesn't do anything yet because there's another way to do it. We're actually just going to copy all of this widget. And we're going to create another screen called the layout page, maybe. Paste that in. You need to import material. I'm going to do Command D to select all the My Home Page parts, and we're going to do layout page. And let me change the title at the top so that you know that this is indeed the layout page. And this one, we don't need a button at the top. And in the main screen, let's be able to click into it so we could actually see what that screen's all about. Going to do Navigator of context. Push a material page route. I'm going to push the layout page. All right, if we go to this, looks the same. I think it should still be responsive just like the previous one, and it is. But we're going to do it a different way. So let's remove the media query that we used. And what we're going to do instead is wrap this big display in a widget called Layout Builder. Now, when we use a layout builder, we get this constraints property. And when we take the constraints, we can check the max width. If the max width is greater than 500, so we want to make sure this is an if statement, we can return big display. Otherwise, return small display. So this should do the exact same thing that we did before, just using a different method. There we go. It works the same way. So why would you use one versus the other? Well, you actually can use either of them. It doesn't really matter too much, but what I choose is to use media query for maybe one-off things that you won't use everywhere. And I'd use the layout builder for complete full-page layout alignments. You can wrap the whole page in this layout builder and have it display just as you want for the complete page. And maybe for media query, if I want a button to show up there or not, just one thing, I'd use media query. Also, the constraints do give you more information, so you could make it more perfect and aligned to just how you want it. But that's how you build responsive layouts. There's two methods using layout builder and media query, and they allow you to build your website to interact properly on all the screens. So Flutter can deploy to all these different platforms, but that doesn't mean you should treat all those platforms exactly the same. Specifically when it comes to UI, all of them have their own little differences, and they even have some differences on how they act. So you need to make sure you keep those things in mind and develop to that accordingly. So what we're going to cover is mobile versus web UIs. Now there's also desktop, but I'd say desktop is pretty similar to web UI other than like the address bar and back button. Let's go over some of these differences. So the first one is it's obviously a completely different screen. A phone screen's a lot smaller, more vertical, and just like thinner to work with. While a website screen is a lot more horizontal, and it's just bigger in general, and there's an address bar and all that stuff. So what does this mean? What does these different screens actually bring you? So the first one, you got to make sure you think about layout. For phone, it could be laid out a couple ways. It could be portrait like this, or it can be rotated, and it could be landscape. While a website can really be any size. You can resize this to be bigger, smaller. Any size works for a website or a desktop application. You also notice since it's more horizontal, you're able to fit more stuff on an actual website. And almost everything is clickable from here, while on a mobile device, there's menus that you need to open in order to access some of these features. The next thing is the way you interact with it is completely different. On a mobile device, you're swiping, you're pressing buttons with your finger, you're pinching and zooming in, doing things like that. While on a website, you're using a mouse and usually clicking, and you have a scroll wheel on the mouse. Maybe you're using a touchpad, but the way you're interacting with it is completely different. One thing specifically to keep in mind on desktop or websites is that you usually have a lot of features that work when you hover over it. So for example, on Twitter, if we hover over the name, you'll see it gets highlighted to let you know that you can click it. There's no way to really hover within an application. So you have to keep those things in mind on how your app works and acts. Next thing is navigation. Usually within a website, all the navigation is just out there and ready for you to use. So we have all these different tabs we can go to here. We have different lists we could go to here. While on a mobile app, you would have to click this in order for it to open up a menu where you can select to go to a different one. Twitter actually has a bottom navigation bar too for some of these like notifications and messages. And then the lists, you can swipe through the lists. And there's also specific features between the platforms. So there is notifications. That's a big one with apps. You have to design the notification, what a push notification looks like. within the actual app, you should show that there's a notification somewhere. And that's the part of the UI that you got to think about, as well as a feature that you would probably need to add if you're building an application. Another one is you have access to GPS. Now, for Twitter, you might not need this, but depending on what application you use, that might be a really important part. For example, finding your location. If you want to see tweets that are posted that are pretty close to you, you'll need that navigation feature. And in general, there's just different ways to interact with it. On mobile, pinching to zoom is such a common feature, while on the website, you're just scrolling. So you got to make sure those are all handled in each of the situations. Now, for the web-specific stuff, we have cookies. Cookies are little bits of data that are stored on your actual browser, so you can keep little pieces of information like maybe what mode, whether it's dark mode or light mode. Now, you could do that with local storage on your mobile application, but those are still differences that you got to keep in mind. The next big thing you got to keep in mind is a lot of people use ad blocker on websites. So if your app does have some ads on it, maybe when you port it over to being a website, that space will be empty. So you need to make sure that UI is consistent with that, and you think about what it would look like if an ad was blocked in that case. Another thing that's web specific is you do have that browser bar. So people can access direct little pages within your Flutter app, and you want to account for that type of stuff. And just note that there's some more UI elements above where you are having your actual website. So like I said, Flutter is great because you can deploy to all these different platforms. But just when you're working with them, remember that each of them have their differences, and you can make sure you account for all of those. So Flutter can deploy to all these different platforms, but that doesn't mean you should treat all those platforms exactly the same. Specifically when it comes to UI, all of them have their own little differences, and they even have some differences on how they act. So you need to make sure you keep those things in mind and develop to that accordingly. So what we're going to cover is mobile versus web UIs. Now there's also desktop, but I'd say desktop is pretty similar to web UI other than like the address bar and back button. Let's go over some of these differences. So the first one is it's obviously a completely different screen. A phone screen's a lot smaller, more vertical, and just like thinner to work with. While a website screen is a lot more horizontal, and it's just bigger in general, and there's an address bar and all that stuff. So what does this mean? What does these different screens actually bring you? So the first one, you got to make sure you think about layout. For phone, it could be laid out a couple ways. It could be portrait like this, or it could be rotated, and it could be landscape. While a website can really be any size. You can resize this to be bigger, smaller. Any size works for a website or a desktop application. You also notice since it's more horizontal, you're able to fit more stuff on an actual website. And almost everything is clickable from here, while on a mobile device, there's menus that you need to open in order to access some of these features. The next thing is the way you interact with it is completely different. On a mobile device, you're swiping, you're pressing buttons with your finger, you're pinching and zooming in, doing things like that. While on a website, you're using a mouse and usually clicking, and you have a scroll wheel on the mouse. Maybe you're using a touchpad, but the way you're interacting with it is completely different. One thing specifically to keep in mind on desktop or websites is that you usually have a lot of features that work when you hover over it. So for example, on Twitter, if we hover over the name, you'll see it gets highlighted to let you know that you can click it. There's no way to really hover within an application. So you have to keep those things in mind on how your app works and acts. Next thing is navigation. Usually within a website, all the navigation is just out there and ready for you to use. So we have all these different tabs we can go to here. We have different lists we could go to here. While on a mobile app, you would have to click this in order for it to open up a menu where you can select to go to a different one. Twitter actually has a bottom navigation bar too for some of these like notifications and messages. And then the lists, you can swipe through the lists. And there's also specific features between the platforms. So there is notifications. That's a big one with apps. You have to design the notification, what a push notification looks like. Within the actual app, you should show that there's a notification somewhere. And that's the part of the UI that you got to think about, as well as a feature that you would probably need to add if you're building an application. Another one is you have access to GPS. Now, for Twitter, you might not need this, but depending on what application you use, that might be a really important part. For example, finding your location. If you want to see tweets that are posted that are pretty close to you, you'll need that navigation feature. And in general, there's just different ways to interact with it. On mobile, pinching to zoom is such a common feature, while on the website, you're just scrolling. So you got to make sure those are all handled in each of the situations. Now for the web-specific stuff, we have cookies. Cookies are little bits of data that are stored on your actual browser. So if you keep little pieces of information like maybe what mode, whether it's dark mode or light mode. Now you could do that with local storage on your mobile application, but those are still differences that you got to keep in mind. The next big thing you got to keep in mind is a lot of people use ad blocker on websites. So if your app does have some ads on it, maybe when you port it over to being a website, that space will be empty. So you need to make sure that UI is consistent with that, and you think about what it would look like if an ad was blocked in that case. Another thing that's web specific is you do have that browser bar. So people can access direct little pages within your Flutter app, and you want to account for that type of stuff. And just note that there's some more UI elements above where you are having your actual website. So like I said, Flutter is great because you can deploy to all these different platforms. But just when you're working with them, remember that each of them have their differences, and you need to make sure you account for all of those. Sometimes as you're running your Flutter apps, you might run into some real nasty bugs that you can't really solve using the normal debugging with breakpoints, call stack, and just maybe print statements. But thankfully, Flutter has a whole set of developer tools to try to help you figure out what that problem is. Now, you can access them in VSCode by pressing Command or Control-Shift-P and then open Devtools. If you type it out, they can show you all the different Devtools that you have. Now we're going to go over 3 problems that might be easy to spot if this code wasn't demo code, but if you have a problem like this in a real application, it might not be so easy. So this is the first problem. You see we have an overflow. There's the second problem that you might not notice, but there is a problem there. And this one as well, you might not notice from the video, but it's running a little slow. So you see, when we go back to this first screen, you already have a problem. It says the render flex overflowed by 680 pixels on the right. So we have a layout problem. Click this button that says Inspect Widget. Now if we click it, let's increase this. This is a developer tool called the Widget Inspector. Now the Widget Inspector gives you your whole widget tree of the application, and specifically the issue section. So this is where we're struggling with. This is the problem section. And we'll see it's a row with an image, and to the right of the image is a padding. And both of them have a problem with the width being unconstrained. Now, how do we fix that? We can set their flex value maybe to 1 here. We see that doesn't fully fix the problem. It's still an overflow over there. So we can do that to the padding. Set it to 1. And they both have a flex of 1, which means they take up half of the screen. And see, our Flutter code is fixed. The UI looks right. This is how we want it to look. And we don't see that error anymore. But this doesn't actually update our code. If we reload it, we'll see the error is still there. So once you figure out the error, and let's go back into that row. Once you figure out that error, we saw that this was a flex problem here, and then flex over there. And set that to flex 1. We want to be able to fix this in our code as well. So just to kind of showcase what flex is, this is saying it's taking a 1-to-1 ratio to fit this within the screen. If we set the padding to maybe like a 3-to-1, we'll see it takes up most of that ratio of the screen. But we know what the problem is. It means it's expanding this way too much. We can fix it within our code now by wrapping this in a widget called expanded. So expanded just sets the flex to 1. And then we also want to do the same thing here. Expanded. And we can save it and now reload it. And you see our problems are gone. So that's the first dev tool and what it does. Now let's scroll over to the second one. This one can be a little harder to spot and you might not actually notice it, but there is a problem here. For this dev tool, we're going to open a dev tool called, I believe it's performance. Yes. So you shouldn't really be doing this with a debug session. You should be doing this with a real mode, but just for this demo, we're going to be fine with the debug session. So what do you get here? Well, you can track performance of your application. We can actually bring up this screen, and you'll see we have this little performance spike. There we go. There was the performance spike. There we go. And then we can actually pause that and then go back to that performance spike that we saw. If we click on here, no analysis data available for this frame. So we need to be able to track it using more detail. We'll click this, track widget builds. Let's just do all of them. Now this obviously will make your app run slower, but we're okay with that because we want to figure out what's going on here. Oh, we saw it there. Okay. Let's go to the very last one over here. Now if we click into that, select a frame to see more details. So we have an analysis. We see that there's a jank detected. Well, jank means that you had a slow rendering of that specific frame. Now if we go into this section, we can actually see what was causing that problem frame. So there we go. We see that jank within the timeline view. And if we look through all the things that are getting built out here, we see we have the layout, we have the build, then we have this thing called expensive widget. Now this looks like it could be something. Now if we zoom in, expensive widget has a stack. And if we zoom in more, you just see a bunch of text here. So this, we could try to search for something maybe called expensive widget within our application. We do a search for expensive widget, and we see something that pops up. Here, we're actually returning the expensive widget if we get into index number 20. Okay, if you look closely here, you can see 20 is a little bit bolded. Now, what is this expensive widget? We see instead of just printing one index, we're actually looping through 1,000 times and then printing this index 20 over on top of each other. So 1,000 times this index 20 is printed one on top of another. Of course, that's going to create some sort of performance issues in our application. Now, this is, of course, a simple example, but if you were having performance issues within your app or some jank issues, this is the right tool to go track them down. So that's performance. We have the widget inspector. Now let's go over to the last screen. So for this one, you'll see we're tracking everything up there. As we start scrolling, oh, it looks like it's having a lot of issues. So let's open up another tool called the CPU Profiler. Again, we have this problem about the debug mode. So turn that off, and then we need to record it to get some information about what's going on. So let's record that and then see what type of information we get. Process all those samples, and we get something called a bottom-up chart. Now, there's different ways for you to look into this. There's this CPU flame tree, which you can go down the list and try to figure out what's wrong here. And you'll see we have some orange here, which probably the thing that's wrong, so Fibonacci. You have the call tree where you can go through. You see this takes up 95% of our CPU. You can go down this call tree and try to find something. See 90%, 90%, 90. You can keep going down this, but eventually you should find something that says Fibonacci. And there it is. You finally, after a lot of scrolling, I wouldn't recommend this method, but you got Fibonacci over there. Actually, it's Fibonacci within Fibonacci, so there's a lot of Fibonacci's going out. But I would recommend this bottom up chart because it shows you what is taking the most CPU. And of course, again, it's the Fibonacci. So if we go to our code, we can search for Fibonacci. Or since I actually know what the problem here is, we can just go to the performance screen and we'll see we're returning this function Fibonacci for a value of 30 for every single one of these. Now, if you don't know, this is a recursive algorithm that is very computer intensive, and especially for doing it 30 times. So to solve this, maybe you would want to have a different thing getting calculated. Maybe you want to use some sort of different method, or maybe you want to pre-calculate it before we go to this screen, because we're just printing the result a bunch of times, which Doesn't really make sense. And there's some other tools, so let's just quickly cover them. But those are the main ones that I have used most often. So if we look at Devtools, there is a network page which tells you what kind of requests have been going out to the network. Since this app doesn't communicate with the network, we don't really have to worry about that. But normally you see anything going out over the internet. Then you have the memory page. So if something's taking up a lot of memory, you can look here. You'll see what is the total size, how much memory it's taken up, and why. You could actually take a snapshot of all the memory. And our app crashed there probably because we were doing a little too many things at once. But you can check all the memory related stuff in here. If you're having memory issues, if your app is taking up too much memory, you can figure out what you can remove from there. And the last tool is a logging tool. That one just shows you all the logs that Flutter is putting out. You see most of them are from Flutter Framework. And if we do stuff, you'll see there's going to be more and more logs popping out. And we can even search through all the logs. You can check this. You find one of one for are we having a good time? This log popped out, and we can kind of try to figure out what's going on with our application using those logs. Now that's just kind of an alternative to doing print statements, maybe a more organized way of doing them. So that's how you use Devtools within Flutter. State management is one of the most important topics to understand. Like we talked about previously, state is just data. And a lot of an application is just displaying and manipulating that data. And it can get real messy and out of control without state management. So, state management is the theory about how you control your data within your application. And there's two specific things that state management needs to do. One is manage and manipulate the data, and two, let the UI know when it needs to be updated because the data has changed. Now, Flutter actually has some solutions to this, specifically one that we've actually ran into before, and that is set state. Set state is the simplest state management within a Flutter application, but set state by itself only lets you manage the data within a specific widget. But Flutter also provides you a way to use it and manage data throughout a whole application, and that's using something called inherited widget. Now, a definition of inherited widget is a base class for widgets that efficiently propagate information down the tree. Basically, it allows you to give data to the widgets below it in the widget tree. So if you maybe add an inherited widget all the way up here, all these widgets below it will be able to have access to that data if needed. The thing is, inherited widget isn't actually used that much. We're going to actually walk through an example of how to use inherited widget and how you would use it if you had to, but it's very verbose. Most developers actually use some sort of state management package. This will cover a lot deeper with one package in specific. The reason you use a state management package is because it does the same exact thing, but it simplifies it a little bit. But not just this, but some packages add some actual nice features to make sure you're always checking out all the cases, whether it's errors or loading, and gives you easy access to update the UI. There are a ton of packages out there. They all pretty much accomplish the same thing, so feel free to choose and work with one that you enjoy. But the one we're going to be working with is Riverpod in the next lesson. But before we get to that, we're going to go through an example of an application that I built with inherited widget itself. Now in this lesson, we're not going to write out the actual code. What I want to teach here is the actual theory and the basics of how a state management package works. And I think in the next lesson, when you go through it, where we actually go deeper into every part, you'll see a lot of similarities that we see here. And maybe if you don't understand everything the first time going through this lesson, after checking out the next two where we use a package, you can come back to this and you'll see how Flutter implements it by default. And so what we're going to be doing there is turning this counter that we have into an app state. And it might maybe even seem unnecessary, but at the end, I will show you what this allows us to do. So we said there's two main goals with state management. First is dealing with the data. In order to deal with the data, we have to define the data first. So this is the app state of our whole application. And you'll notice it's just the counter that we have. This is the state that we're going to be managing throughout this video. And below it, we have our inherited widget that we will be using. We create a class and we named it provider because it's going to be providing information or data to the rest of our application. Our next part we said is we need to insert this at the top of our widget tree in order to be able to propagate that data down. So if we go to our main file, at the very top you'll see we have defined an app state holder. If we jump into this app state holder, you see at the bottom it has a provider in it. So this provider is the inherited widget that will be passing down this specific data throughout the rest of our widget tree. And we created this app state holder to actually manage that data. So up here, we initialize the data, and we have one function that we add to it called add, where it lets us increment that specific data. And you'll notice we call setState to update the rest of our application that this data has changed, and anything using this data needs to update as well. And finally, we get to displaying this data. You'll see we call provider.ofContext. So this context goes up our widget tree, finds the provider, and returns the counter that we have for it. And to increment, we get the app state holder, which had the functions where we can add and increment the counter that we had and see that change here. Now let's stop for a second and what the heck are we even doing here? You can see the counter works the same exact way, but we just went through that whole headache of setting up this whole state management solution just to have the counter work the same way. Why? Well, there's something very special we can do now. This state isn't tied to this one screen. We actually have the second page, which in other applications that we built, the second page, it starts from scratch. But here, the state is actually saved. Not only that, we can update the state from our second screen, and if we go back, you see it's updated here as well. This might not seem that powerful when we're doing it with a counter, but when we're going to be doing this with actual user information, if you go into some screen where you want to update a username or something, you update it there, and it gets updated throughout our app wherever it's used. So that's one of the big power features of state management. You get to use state throughout your whole application. And the second big power of it is that it's organized. So let's say for some reason our counter is not working right here. We actually wanted to increment our counter by 2 instead of 1. And not just that, we want the same thing on both pages. Normally, we'd probably have defined it in 2 places. We'd be passing it around, and we have to update our function twice. But we'll know everything's organized. The only way that our state gets updated is through the functions defined here. So all we need to do is update this from +1 to +2, save it, and it gets incremented by 2 on the first page. If we go to the second page, same thing happens. Now imagine, as your app gets bigger, you have tens or hundreds of data pieces scattered everywhere, and you have tens or hundreds of different ways to manage that data. You will know exactly where that data is defined, where it gets updated, and it's all in one place here. Maybe you run into a problem somewhere and you need to fix it. You know exactly where to go to fix that problem. Now in the next couple lessons, we're going to build out the same application except using a state management package. We're building it out from scratch. We're going to cover all the concepts we covered here, except the code's going to be a little bit simpler and easier to understand. And if you're curious, you can come back after those lessons and see how to do it with just the inherited widget and set state. And hopefully at that point, it'll all click and make sense. So now we start working with state management packages. My package of choice is called Riverpod. Now, why choose Riverpod? There's all these other state managements, and there's actually way more. There's probably like 20 or 30 at least. Why did I choose Riverpod out of all of them? For that, we're going to go to the Flutter documentation. If you go to development, then data and backend, state management, and you go to the state management options. You notice the recommended approach by Flutter is using something called provider. This isn't necessarily a state management solution. It's more of a way to easily provide data to your whole application. But people use it and you can turn it into a good state management solution. Now, according to Flutter, Riverpod is another good choice. It is very similar to provider, but it is compile safe and testable. And the story here is that provider is one of the first and best ways to manage state within your application. That's why it's the recommended approach by Flutter. Riverpod actually has the word provider in there, so P-R-O-V-I-D-E-R. So it's provider with the letters jumbled up, and it's made by the same person that made provider. But as he was trying to make Provider better and better, he ran into some limitations. So Riverpod is a second iteration of his efforts into creating a full state management solution and making Flutter development easier. And I can see there's a ton of other state management options there. And it really just comes down mostly to preference. But I've been using Riverpod. A lot of people enjoy it. I think it does just enough to make state management with Flutter easy. The most important thing is to understand the concepts. If you understand the concepts of state management in general, you can switch to most of these state management solutions and work with them just fine. So that's why I choose Riverpod. Riverpod actually has 3 different packages. It has the regular Riverpod, which is not specifically for Flutter, and you can use it for Dart as well. You'll see it's the only one that has the Dart SDK highlighted. Then there's Hooks Riverpod, which uses a concept called hooks that allows you to use Riverpod with the least amount of code. What we're going to do is we're going to use Flutter Riverpod. The reason I like to use this one is because it's not oversimplified like hooks, so you kind of get a good gist of what's going on under the hood, and it's specifically made for Flutter, so it works very nice with Flutter applications. Like I mentioned, state management needs to do 2 things. First, it needs to be able to manage and manipulate the data, and second, it needs to be able to update the UI. Riverpod does this using 2 concepts, provider and consumer. Now, if you remember in the last lesson how conveniently I named that one class provider, it's very similar to what's happening here. The providers provide the data to the rest of your application, and the consumer is the one that takes the provider in, and whenever it changes, it updates the UI. The way Riverpod is set up is there's different providers for different types of data. So there's a regular provider that just provides whatever you give it to the rest of your application. Then there's Futureprovider, which provides futures to your whole application, but it gives you some nice safety features. For example, makes you handle loading and error states as well. String Provider is very similar, but for streams. And the last one is the big special one that actually helps you with the whole data management and manipulating part. It's the one that I would call a full state management solution. With Statenotifier, you can add functions. For example, on our counter, this is where we would add the add function. So that's a very high level of Riverpod, and we're going to walk through all of these, starting from the basics and diving deeper and deeper. So first, we need to actually define something to provide to the rest of our application. We're going to set up a file called providers.dart. Actually, before that, we need to add Flutter Riverpod as a dependency. So you can add it like that, and I'll add it to your code base, and now you can work with it. And actually, let me give a shout out to this extension called Flutter Riverpod Snippets, which makes it easier for you to create those providers because they provide little snippets that you just type out in a couple letters, and it gives you the whole syntax for the provider. So for our first provider, we're going to start writing a provider. This is from the snippets. You'll see provider pops up. If we click on it, it gives us a syntax. We're going to call this just a normal provider. And it's going to provide us a string value. We need to import Flutter Riverpod so it knows what's going on. And for that string, we're just going to have it return a string that says, I'm just a normal provider. Okay, now let's go back to our main.dart. Remember, we had to add it above our widgets in the widget tree in order for them to have access below it. So we need to do the same thing here. In this one, we're going to do it with something called a provider scope. And we need to import it from Flutter Riverpod package as well. So the provider scope here allows us access to all the providers which we're going to define within this providers.dart page. And actually, that's all the setup we need for the data part of things. Now, this is just a simple provider that allows you to access data anywhere. But when we move on to the next section, was actually showing that data. And for this, remember, we use a consumer. So here we put out a widget named consumer. And what this consumer does, it gives us this ref. So this ref is a reference to all the providers that we have. And in order to read those, we do ref.read. And we want to read our normal provider. And that's actually going to give us the string, so we want to make sure to return it in a text. And we want to make sure to actually return it first. And that's it. That's Riverpod, the very basis of it. And it says no provider scope was found, so we need to make sure to restart the application. And there we go. We're able to access this data anywhere within our application. Now this is oversimplified, so let's add a bunch of layers to this. So the first thing we did was we did ref.read. This reads a provider without listening to it. In this case, that definitely makes sense because there's no changes going on with this provider. But there's also ref.watch. So watch reads the provider and then also listens to any changes for it. So let's say this normal provider was something that could update, would be able to update it, and our UI will get updated automatically. But for this, let's keep it as a ref.read. Next thing I want to show you is something called consumer widget. So instead of having to write consumer every place where you want to use it, you can change the stateless widget to a consumer widget. And this consumer widget comes with that widget reference right within our build method. This is just to clean up your code to make it easier to write. It doesn't change anything about how it actually works. But you saw we needed to write the consumer first to get that reference. Now we have that reference already in our widget. So you can save it and it looks exactly the same. So let me walk through that because this is basically the gist of Riverpod. So first you need to create a place to manage and provide the data. We'll do that using providers, and in this case we did it in a separate file, but you can do it anywhere. You define them here, and they get provided to your application using a provider scope, which is set up at the top of your widget tree, so everybody below can get access to that. And then you consume that information using a reference to those, which you can get using a consumer, and then you can either read or watch that specific provider. That's really the gist of Riverpod. The layers we're going to be adding on in the next lesson is we're going to be adding different types of providers. But the overall concepts of how it works are all covered here. Let's move on to Futureprovider. A feature is an asynchronous event, for example, a call to a database, and it takes time for that request to go out over the network, get the data, and return it back to you. Now, there's two things you need to account for: the delay between seeing that data, and sometimes there could even be an error. The nice thing about Riverpod is it handles those states for you. So let's go ahead and create a future provider. I'm going to name this one message provider. Now we're just going to be returning a string just like before. But the thing we're going to do here is we're going to do a future delayed with a duration of 3 seconds. Actually make it 5 seconds. So what this function does is we're going to wait 5 seconds before actually giving the string back. And then we're going to return a message from the future. So we're just faking the delay because if we didn't fake it, it might happen too fast. We might not even see the loading state. And in general, it's the same exact concept as going to a database, taking time before coming back and actually getting that message. So our future provider is defined here. If we go back to the main now, we want to display this future provider. We're going to have a message for this one. And just like the normal provider, we're going to do ref, but instead of read, we're going to do watch. And we're going to watch the message provider. Now here's where it differs a little bit from the previous provider that was just normal. The future provider handles those 3 different states that I said: the actual getting data, a potential error state, and a loading state. So to get those, you do period and then when. And there you go, all of them pop up. So for the data part, we get past the actual, let's call this message. And if we actually have the data, we could just return that message. An error state gives us the error and the stack trace of it. But for us, we can just return a text that says error. And then with the loading state, we can return a text that says loading. And see, I refreshed it. It's loading for 5 seconds. And there we go, a message from the future. So if we rerun this application, and actually let me change this up a little bit to make it a little cooler. Instead of returning always a text, we're going to return a text for the message, text for the error, but in the loading state, we're going to return a circular progress indicator. Okay. Now, if we refresh, you'll see where you get a little spinner when it's loading. It should load for 5 seconds, and then we should retrieve our message. Perfect. When you're just writing code and you're using futures all over the place, it can sometimes be hard to remember, or maybe just a little reminder whenever you use a future provider that you have to deal with these right when you write it. And in this case, we actually have to make sure we use the ref.watch, because let's say if we change it to read and save it and reload this application, it's just going to read that once. And the first time it reads it, it's going to be in a loading state, and it's never going to read that loading state because we don't get the information after 5 seconds, and we're not watching for any changes within our future. So if we change it back to watch, it should all work now. That's a regular provider. That's a future provider. A stream provider is actually very, very similar. It has the same loading and error states, but these obviously get updated more because they can be streams and you can get that data continuously coming through. So those are the basic providers that just give data down your widget tree. Now we have the full state management solution using state notifier providers. Now this is where it gets fun, because we can bring back our beautiful, sweet little counter. We do that using a state notifier provider, which is the final piece of our state management requirements, which is manipulating the data. Now, displaying the data is going to be very similar to what we did with the other providers. But the key difference here is it's another different type of provider. So let's go ahead and create it. Because we have the Riverpod snippets, we have the state notifier provider ready for us there. We're going to call this the counter provider. And our state notifier provider gives us access to two things: the counter notifier and the actual count, which is going to be an integer. And the thing we're going to be returning here is our counter notifier. So you see there's a problem. We haven't defined this counter notifier anywhere. That's because we need to define it here, and we're going to call it counter notifier, which is a state notifier. Let me finish filling this out, and then we'll cover what exactly is going on here. So our state notifier is the one that's actually doing the work. This is where the state will be held and where all the actions upon it will be done. The state notifier provider provides both our counter notifier, which will have all our functions, and the actual state, the current state, which is an integer since it's a count. So you can think of the state notifier as the little worker actually doing all the stuff, and the state notifier provider is like the boss giving people access to everything that you're doing. So first, we put in the super a 0. That's the initial value of our counter. But we can add some functions to it, like the add function. Now, a state notifier is immutable, which means that nothing can change the state of this. The state doesn't change. That means every time you are updating the state, you actually need to completely reset the state to a new value. So to do this, we can't just do state plus plus like we would. That doesn't work. We need to set the state to our previous state plus 1. And that's our state notifier provider basically handled. Now we can actually showcase it. Before what we were doing this ref.watch within our actual column. But you can do it up here, especially if you use it multiple times. This is where it becomes really useful. Let's actually remove these children for now to make it a little bit cleaner. So to get our current counter value, we do ref.watch. And remember, we need to watch it because the counter will be updating, and we need to get those updates back into our UI. And we're going to be just watching the counter provider. This gives us the counter. We can actually just display the counter right away because it should be 0, but it has a value. Counter. Save. So our counter is at 0. Let me just, this is definitely not necessary, but let me give it a little style so it's a little bit bigger. Okay, now we have a bold and bigger counter. So the state is there, but how do we update it? Remember, the notifier is the one that actually does the updating of it. So we need a counter notifier. We need access to that thing. And I like to call these controllers. Maybe we can even call it a counter controller, because this is the one that actually controls that data. For this, we do ref.watch. You find the counter provider, but then you take the notifier from there. So when you do this .notifier, instead of just getting the data, you're getting access to this specific notifier, which gives you access to this specific function. Now down here, we could add a button. Whenever you press this button, we get the counter controller, and we can add something to it. We can give it a child that says add. All right, so there we go. That's our full state management solution. If we click this, you see our counter gets updated. Now let's actually add another screen so we know that this data is app-wide and not just on one screen. So what I'm going to do is copy this widget. We'll actually just paste it down here just for simplicity. We'll call this second. Say counter on second screen. Actually label it same counter on second screen. Let's add a button that says go to second screen. And here just get our navigator like we've done multiple times of this current context. Push a material page route of our second page. Okay, so now we go to our second screen. We should see the same counter with a 5. Perfect. And we can add on to that counter. Goes all the way up to 18. Now this is a little too much text. We can just remove some of this so it's in the same row, but we see we're able to add stuff in here. We're able to go back. The counter is still the same counter. And if, let's say, we want to change the counter logic or our whole application to add by 2 instead, we save it in one place, and it adds by 2 here, and it adds by 2 here as well. So that's the magic of state management. Especially as your apps grow and become bigger, this is going to become a more important part of your app building process. It not only keeps you organized, but allows you to use that same state across different places of your application and maintain it. And depending on which package you use, you get some extra features. For example, with Riverpod, whenever we're using a Futureprovider, it makes sure that we handle all the other possible states. So that's state management. And now we can move forward with the rest of our Twitter application. Now there are a ton of state management packages out there, but which one is the best one? Honestly, this is a bit of a heated topic in the Flutter community, and the word best is definitely subjective. There's no such thing as best one because everybody has their own opinion and their own things they value and their own definition of best. But there is a best one for you, and I'm going to give you at least my opinion for which one's the best one for me and why I believe that, and then you can make your own decision after that. Now, here's a list of the top 30 Flutter state management packages. And like I said, there is a ton of them. And I'm not showing you this chart that you need to go and look through every single one. I'm just showing you to tell you how many there are. There's so many of them. And I haven't been able to look at all of them, but I have been able to look at some of the biggest ones. So I'm going to cover those biggest ones and my opinions about them. So Flutter Block is a very popular state management package in Flutter. It is a Flutter favorite package, and it is used by a lot of the people in the community. In my personal opinion, it is a little bit verbose. There's a lot of boilerplate, and maybe it's just because I'm not comfortable with it. I haven't used it that much, but I don't really choose it. There's just a lot there is to know. But it is a Flutter favorite. It's very popular, and there's a lot of community support about it. And the last thing is they do have a very nice documentation at blocklibrary.dev. They can go into, get started, and learn all about it. So it's a great package, but just not my first choice. Now, onto this one, which is the most popular package on the whole Flutter pub.dev. But just because it's the most liked one doesn't necessarily mean it's good. It just means most people liked it. And I actually wouldn't really recommend this package that much. Even though it's the most liked, it abstracts a lot of the Flutter concepts. For example, it doesn't use Buildcontext, which we learned about, which is kind of steering away from what Flutter actually is. Second biggest thing is it definitely lacks documentation. So sometimes it's hard to figure out what things are doing what. But the worst part about it is it hasn't been updated in 8 months now. And the pre-release hasn't been updated in 5 months. Now for a Flutter package of this size, and if you go to the repository, it has 700 issues, 70 pull requests that all haven't been worked on. So I feel like at this point, definitely be a little wary if you choose to go with this. Now, next one I want to cover is Provider. This is one of the earliest state management packages out there. And see, it definitely has a lot of likes. It's also a Flutter favorite. And it's just a good package overall. It's actually probably the most used Flutter state management solution out there. That's because it's been around for so long. So it's proven and it's robust and it's very popular. The only problem with it is it's not a full state management solution. It's made to give you the providers. So it allows you to, within your application, reach out to these providers and get the data from them. But like I said, state management solutions have two parts that need to fill. The first need to provide the data and then have a way to show and consume that data. So the developer that made Provider made a second iteration that used what he learned from Provider and made it even better with Flutter Riverpod. Now, Flutter Riverpod is what we use in this course. And you'll notice it uses the same providers that are used within Provider. But the other thing it does is it has consumer widgets. So you're able to use those providers really easily within your app. It also has great documentation about almost everything you need to use within Riverpod. So it's a great tool. So now what does Flutter recommend? Like I said, Provider has been the one that's been around for the longest. So it is the recommended approach by Flutter themselves. But this text right here has been around for, I think, like 3, maybe even 4 years. So maybe they just haven't looked through all the options and updated yet. But they did update this part recently. They added Riverpod. And you notice it says Riverpod, another good choice. It's similar to Provider and is compile safe and testable. So this is why I usually choose Riverpod for all my packages. It's built by the same person who has the package that's recommended, but he thinks this one is better and actually executes state management better than Provider did. And fun fact, if you see the letters in Provider, if you reorganize, it'll give you Riverpod. So those are the state management packages. But there's one more that shouldn't be forgotten, and that's just set state. You don't have to go into every project thinking that you need some sort of package to do your state management for you. If your app is simple enough, you can just use set state. Now the benefits of using set state is it's simple. It's built into Flutter, so you don't need any dependencies. You just use what is given within Flutter. And it is really a good solution for small apps or maybe apps that are bigger but don't necessarily have that much data to manage. I think set state should be the default you go with, and then think about how big your application is going to be. And if it is going to be big and you need something else, I personally recommend Riverpod, but there are other good solutions out there.
Nice work! You've just taken your first steps into Flutter, but what you've learned here is just the beginning. If you want to go from beginner to professional who can actually get hired, you need the full picture. In Tadas' complete Flutter Bootcamp course, you'll go much deeper. You'll dive into advanced concepts like complex animations and automated testing. You'll even build a full-scale Twitter clone featuring user authentication, user profiles, and real-time data. Plus, we'll show you exactly how to deploy your apps to the Apple App Store and the Google Play Store so that the rest of the world can see what you've built. By joining the Zero to Mastery Academy, you not only get full access to Tadas' Flutter Bootcamp course, but every other ZTM course and priority support from our world-class mentors inside the Zero to Mastery community. If you enjoyed this crash course, please drop it a like, leave a comment, and share it with someone who wants to learn Flutter. That's it from me, and I look forward to seeing you inside the Zero to Mastery Academy.